अस्सलाम वालेकुम एवरीवन, क्या हाल चाल है आप लोगों के। बस 1 मिनट दें, स्टार्ट कर रहे हैं। सर जैन की स्ट्रीम चल रही है या ख़त्म हो गई? वालेकुम अस्सलाम, वालेकुम अस्सलाम। डर लग रहा है कल के लिए? बिल्कुल लगना भी चाहिए भाई, इतने महंगे पेपर हो गए तो फिर डर लगना भी चाहिए आपको। टू नॉट मेस इट अप। Today is the last showdown. Yep, today is the last showdown. Although this is the second last stream, I will be doing another stream inshallah at 7:15. A very quick and brief syllabus run through. Okay, don't expect me to cover every topic from scratch. That's obviously not possible. Okay, that I will do inshallah at 7:15 tonight. ठीक है। अच्छा एक सेकंड यार, मैं ज़रा ये विंडोज़ क्लीन अप कर लूँ, फिर हम बात करते हैं। 1 मिनट दें मुझे बस। I guess we're fine. Camera check, mic check. Yeah, we're good. Okay, so let's begin. Sir, you'll be doing momentum with kinematics in the stream? Yep, so I'll be solving all the types of questions that we have with momentum, whether it's momentum with kinematics, whether it's momentum with work energy power, all of them inshallah. Okay? Sir, could you do February, March, question 6, it's momentum. February, March what beta? February, March 2020, 2021, 3, 4. अच्छा अभी ज़रा ये अपनी फरमाइश है अपने पास रखें, ठीक है। अभी ज़रा फ्लो तो बनने दें क्लास का। लेट मी स्टार्ट विद सम इजी क्वेश्चंस, ठीक है। लेट्स जस्ट बिल्ड सम मोमेंटम, ठीक है, एंड देन वी विल डू द डिफ़िकल्ट वंस, ठीक है। सो टेक इट ईजी गाइस, टेक इट ईजी। सो लेट्स डू द फर्स्ट 3 questions I would say of this worksheet before we do the complex ones, ठीक है। 3 or 4 questions of this worksheet. So starting with the first one, this is perhaps the very first momentum question there is, or if not the first, maybe the second one. Let's see, let's find out, let's see what it says. So this question says particle speed. Achha, before I start, I would appreciate if you guys like the stream. Sir जी Dropbox worksheet में ऐसा कैसे हो सकता है? मैंने खुद वहाँ से अभी खोली है worksheet। अच्छा एक चीज़ हो सकती है कि मैंने लिंक लगाया ही ना हो। एक सेकेंड, आमना अगर ये आप कह रही हैं बिकॉज यूर अ रेगुलर, तो मैं मान लेता हूँ आपकी बात। आई विल जस्ट रिफ्रेश द लिंक। कोई और कहता तो मैं इग्नोर कर देता। चलें आप चेक करें। Where to access your Dropbox? Just check the link in description. You will find this worksheet there. Can you guys quickly check if you can find the link to this worksheet? Yes or no? S1 inshallah from the 6th. I've already made a schedule for the streams on the 6th, which is tomorrow. Okay, so tomorrow evening onwards we will start S1. Yeah, we'll have a syllabus recap stream at 7:15 inshallah. The link is there. Okay, great. So let's begin now finally. So the question says particles P of, this is the very first question and it's a very basic question. I will be solving difficult questions also, but let's start with the easier ones. Difficult ones we'll leave for later. Particles P of mass m kg and Q of mass 0.2 kg are free to move on a smooth horizontal plane. Now whenever you have a smooth horizontal plane, that means the speed will be constant. You don't have to consider friction. P is projected at a speed of 2 meters per second towards Q, which is stationary, so very important. P is projected towards Q, which is stationary, and the speed of P is 2 meters per second. After the collision, P and Q move in opposite directions with speed 0.5 and 1 meter per second respectively. Okay, what do we have to do? We have to find M. Ab dekho, in momentum, first of all, it's very important for your own sake to figure out which direction is it that you're going to consider as positive. Okay, so we're going to consider the rightwards direction as positive. अच्छा, then at the same time look at the amount of space. अच्छा, momentum की जो amount of space है ना वो बड़ी it's messed up, okay? It's not consistent. It's very inconsistent. Sometimes there will be such a simple question and you'll be given a lot of space. Sometimes there will be a question which requires a lot of working and you'll be given very little space, okay? You'll observe that a bit shortly. So let's make two sketches. One is for the before scenario, the other is for the after scenario. So the before scenario is that you have particle P which is projected towards Q at a speed of 2 meters per second. Okay, so no need to write down the mass. The mass we will take from the question. Let's just write down the speed. And then you have particle Q which is stationary. Okay, that means its speed is 0. Achha, what happens after the collision? Notice that it says that P and Q move in opposite direction. Okay, so P and Q move in opposite direction. Obviously, ऐसा तो possible नहीं है that P continues to move in this direction and Q continues to move in this direction. Okay, it's not like both will go through each other. The only way it's possible for both of them to move in the opposite direction is when P moves in this direction after collision and Q moves in this direction after collision. Okay, is when P is moving towards the right now, but as soon as it collides with Q, then it starts moving towards the left. ठीक है, so common sense पे use कर लेना. ये नहीं पूछना कि आपको कैसे पता कि Q और P इस direction में move क्यों नहीं कर रहे. ठीक है, use your common sense. It's not that P will jump over Q and then start moving in this direction, or Q जो है वो उसके नीचे से will start moving in that direction, or maybe they both will go through each other or something. That's not the case. As soon as they collide, what happens is P and Q, according to the question, start moving in the opposite direction, and that's enough information for us to know the direction in which they're going to be moving in. So P will move towards the left and Q on the other hand will move towards the right. Achha, what's important is their speeds. So P is moving at a speed of 0.5 meters per second, okay, and Q is moving at a speed of 1 meters per second. ठीक हो गया? And that's it. That's enough information that you need. That's all the information that you need to solve this question. Achha, if you look at me solving momentum related questions, I like to make these before and after tables, but you know, there are times when we can't afford to do that because we're not given a lot of space. Here we're given a lot more space than needed, so we can do that. Okay? Now, here's the thing. What's the mass of P? The mass of P is m, and what's the mass of Q is 0.2. Before the collision, P is moving towards the right at a speed of 2 meters per second, so that means its velocity will be 2. Okay, and what about Q? Q has velocity 0. Achha, now be careful. Remember, we're taking velocity, this is speed. P still has a mass of m and Q still has a mass of 0.2 kg. Okay, they haven't coalesced or anything where we take a different mass. Okay, but P is moving towards the left now. P is now moving in the opposite direction. So that means now when we take its velocity, we will take minus 0.5. Okay. And then as far as Q is concerned, Q's velocity will be taken as 1 only. Okay. Now, law of conservation of momentum says that momentum before equals to momentum after. So that means mass times velocity of P plus mass times velocity of Q before the collision is equals to the momentum after collision. So 2m plus 0 equals to minus 0.5 m plus 0.2. Okay, so 2m plus 0.5, when you get all the m's on one side, so this makes it 2.5 m, which is equal to 0.2. Now what about m? M is equals to 0.2 divided by 2.5. Let's see what's that equal to. 0.2 divided by 2.5, that's equal to 0.08 kg. Okay, not that you have to write down the unit. Okay, as I always say, we have much bigger fish to fry, so you don't have to worry about writing down the unit. But anyway, this is a very simple, a very basic momentum question. Okay? Take a good look at it. Let me know if you have any questions. अब थोड़ा हम gradually इसका level up करेंगे. ठीक है? We'll gradually level up the kind of questions that we're solving. Achha, I will solve the questions that you guys are saying. Achha, देखो बेटा, there is no need to spam. I will include these questions. Okay? But I will ask you guys, when I ask you guys to share your queries, I'll do that. Okay? If you keep sharing them unnecessarily, I'm afraid I'll just have to time you out or something. Okay? So we'll do this. This is a question that we will solve, but not immediately. First, let's do this question. Let's do question number 2. Okay, so right now we're just making sure that we only deal with horizontal planes. Okay, gradually we'll start dealing with the more complex ones, okay? If it's rough, they'll give, yeah, of course, if it's rough, you will have the coefficient of friction and the speed will be different. The speed will not be constant. And how will you determine the speed? You will determine the speed through acceleration, okay, and using equations of motion. You'll find out, The question I will solve after this one, I'll do one with a rough plane. Small smooth spheres A and B of equal radii and of masses 4 kg and 2 kg respectively lie on a smooth horizontal plane. Initially B is at rest and A is moving towards B with speed 10 meters per second. After the spheres collide, A continues to move in the same direction but with half the speed of B. Okay, so there's a lot that's going on here. Now let's make a before scenario and then let's look at the after scenario. ठीक है, तसल्ली से diagram बनाए. अच्छा, momentum का, if a question of momentum comes in the exam and if it's a straightforward one, you know, if it's like a single stage like this one, do it immediately. I mean, don't leave it for later. But if you come across a momentum question which involves like multiple stages, then do those. Do any question that involves multiple stages for the very end, okay? Alright, so small smooth spheres of masses 4 kg and 2 kg respectively, let's call them A and B. Sorry, initially B is at rest and A is moving towards B with speed 10 meters per second. So that means A is moving towards B with speed 10 meters per second. ठीक हो गया? अच्छा. Then what happens after the collision? After the spheres collide, A continues to move in the same direction but with half the speed of B. So that means after the collision, if B is moving towards the right, they're both moving in the same direction, okay? Which means, logically speaking, they're both going to be moving towards the right. It's not possible that A collides with B and then it's possible for A to move in this direction, but it's not possible for B also to move in this direction. Okay, so in case you're wondering, how will we know that which direction they're moving in? So just use your common sense. After the collision, it's not, while it is possible for A to be moving in the opposite direction, but it's not possible कि मैं किसी चीज़ को यहाँ से hit करूँ और वो फिर as a result it starts moving in this direction. Okay, that just does not make sense. So after the spheres collide, A continues to move in the same direction but with half the speed of B. So that means if B is moving at a speed of x, then A is moving at a speed of half x. ठीक है? अच्छा, कुछ ज़्यादा ही मैं जगह के मामले में कंजूसी कर रहा हूँ. So let's be generous. There we go. Okay. Now, so we are taking the rightwards direction as positive. Okay. So let's look at the before scenario and let's look at the after scenario. So before you have A and B, after the collision also you have A and B. Here's the mass, here's the velocity. So what's the mass of A? That's 4. What's the mass of B? That's 2. Now what about the velocity? A is moving towards the right with velocity 10. B is stationary, therefore it has 0 velocity. What about the mass of A after the collision? Remains the same. Mass of B after the collision remains the same. Achha. Then B, however, is moving at a speed of x and A is moving at a speed of half x. Now let's multiply. So that's 40 plus 0 is equals to 4 times half x, which is equal to 2x plus 2x. So that means 4x is equals to 40, and we're supposed to find out the speed of B after the collision, which is in fact equal to the value of x. So that means the velocity of B after the collision is equals to 10 meters per second. There you go. That's the final answer. ठीक है? Now, it's asking speed of B, it's 10. Yep, that's correct. Speed of A is 5, but it's not asking for the speed of A. It's asking for the speed of B. ठीक है? Sir, IGCSE paper is probably... Wait, IGCSE आप लोगों का exam हो गया? Wait, you guys are back already? वैसे हाँ, you should be. 2 बजे start हुआ होगा, 4 बजे. कैसा हो आप लोगों का paper? Any IGCSE student watching? Can you tell me how your exam went? Sir, could we draw a figure on answer sheet with pencil for easy visualization? Yeah, you can do that. That's fine. Why does MS give mark for speed of A? I don't know. A third small smooth sphere of mass 1 kg with the same radius as A and B is at rest on the plane. B now collides directly with C. After this collision, B continues to move in the same direction but with 1/3 the speed of C. Show that there is another collision between A and B. Okay, interesting. इंटरेस्टिंग स्टफ. सो अब नोट करो कि ए तो अपना पीछे से मज़े से चलता हुआ आ रहा है. अच्छा, अब सवाल ये है कि व्हाट विल बी द स्पीड ऑफ ए. How much space do we have? Always look at the amount of space that you have, okay, before you start. So we have plenty of space, but still, let's utilize it efficiently. So what is the speed of A going to be after the collision? We know that it's going to be half of the speed of B, okay? So A is now going to move, A is now going to move towards the right with a speed of 5 meters per second, okay? B, on the other hand, is now moving towards the right as well at a speed of 10 meters per second. All right. Achha, then a third small smooth sphere C of mass 1 kg and with the same radius is at rest on the plane. B now collides with C. After this collision, B continues to move in the same direction but with 1/3 the speed of C. So this is the before situation, and let's have a look at the after situation. So what's going to happen in the after situation? In the after situation, A will carry on, okay? A will continue to move at this same speed, but as far as B and C are concerned, as soon as they collide, here's what the question says. Okay, B and C continue to move in the same direction, but B moves at a speed which is 1/3 the speed of C. So that means if C moves at a speed of x, B moves at a speed of 1/3 x, okay? All right, now S1 beta inshallah I will do from tomorrow onwards. Okay, kal you guys can expect an S1 stream. Okay, so this is the before situation, this is the after situation. Okay, now we don't have to deal with A. Okay, we just have to show that there is another collision between A and B. So we'll do that. Sir ji, I'm doing maths at Excel, so aapki syllabus run through. It works, but I'm not sure if it's going to be enough. Okay, it does work obviously, but I'm not sure if it's going to be enough. So here's the before situation, here's the after situation. Before the collision, the mass of B, what was the mass of B? The mass of B was 2. The mass of C was 1. That remains the same even after collision. B was moving at a speed of 10, C was stationary, okay? And after the collision, C moves at a speed of, so let's not call it x anymore since we've already used x. Let's call this y, and this consequently becomes 1/3 of y. So if C's speed is y, then B's speed is 1/3 of y. Okay, now 2 into 10 is 5. 5 plus x is equal to 5 plus x is equals to 2/3 of y plus y. Wait a minute. C को मैंने x क्यों कर दिया? C की तो 0 है. Sorry. C की speed तो 0 है. So 5 plus 0 is equals to 2/3 of y plus y, which means, sorry, this is going to be 20. Okay. So 20 plus 0 is equals to 2/3 of y plus y. So 20 is equals to 2/3 plus 1, 2 upon 3 plus 1. That's 5 upon 3. 5 upon 3y, which means y is equals to 20 times 3 divided by 5. That's equal to 12. Okay. Now remember that this is the velocity of C. Y is basically representing the velocity of C. We took the velocity of C to be equal to y. So if the velocity of C is 12 meters per second, the velocity of B after the second collision will be 1/3 of 12. That means it will be 4 meters per second. Now, how can I conclude that there will be another collision between A and B? That seems a bit odd, no? That in all this working, there is nothing. All this working has nothing to do with A, but this working is with the help of which we're going to conclude that there will be another collision between A and B. Now, why will there be another collision between A and B? Pay attention. So notice that A throughout this time will carry on moving at a speed of 5 meters per second. B, on the other hand, after its collision with C, is now, after its second collision, okay, is now moving at a speed of 4 meters per second. So because the velocity of A is greater than the velocity of B, A is moving at a speed of 5, it's faster than B. So what happens if a particle that's behind is faster than the particle that's in front? Obviously, it's going to catch up and there is a collision possible. So since VA is greater than V of B, therefore, there will be another collision. So make sure that your solution is crisp and clear, and it leaves no doubt to the examiner that you've understood the question and you've answered it correctly also. Okay, so I'll summarize it. I'll summarize what I've done. So the first part is just another momentum question. Okay, so you have B, which is moving at a speed of 10. It's heading towards the particle C, which is stationary. After the collision, C moves at a speed of y and B moves at a speed which is 1/3 of it. Okay, so this is what happens. This is basically the before and the after scenario. So what we do is, with the help of this, we find out the speed of C after collision when we solve the equation, and then with the help of that, we find out the speed of B after the collision, since it's going to be 1/3 the speed of C. Now, throughout this time, remember that A's speed hasn't changed, okay, because it's a smooth surface. So if A's speed doesn't change, A is still moving at a speed of 5 meters per second, and B is now moving at a speed of 4 meters per second. If the particle that is behind is faster than the particle that is front, that means there will be another collision, okay? But if A was in front and B was at the back, there wouldn't have been another collision, okay? Because B would never catch up with A, let alone there be a collision, okay? Okay, so, but the question types are the same. What do you mean? So I always get confused when to use F equals to MA and when to use... See, F equals to MA, we always use F equals to MA, but F is always the net, okay? F is always the net force. Net force means that all the forces that are acting in the direction of motion and all the forces that are acting in the opposite direction. Yes, of course, you can write exactly what I wrote here. Okay? So you have to, it's not that they're different, they're both the same, but if there's only one force, then you can just use that. But if there are multiple forces, you'll have to consider that. Acha, please tell me what question number that is from this worksheet. Tell me what question number that is from this worksheet. And please remember, I'm not taking your requests immediately. First, I want to do some questions. I've already planned some difficult questions. Once I'm done with those, then I'll take your requests. Okay? So in the meantime, I would appreciate if you don't spam. Does it ask for another collision? Yes, it does. It does. There is more. There is more. A and B coalesce during this collision. Find the total loss of kinetic energy due to the 3 collisions. Okay. Now notice that A and B are on a collision course and they do collide. Okay. So A and B right here, they are on a collision course and they do collide. Okay. And when they do collide, what happens is they coalesce. They do coalesce means that they join, okay? And they're both moving towards, they're obviously both going to move towards the right, okay? So what do we have to do? We have to find out the total loss of kinetic energy in the system due to the 3 collisions. So total loss of kinetic energy, let's do that. So here is the before situation, here is the after situation. So let's make a table for the before situation, let's make a table for the after situation. So we have A, B, mass, velocity. How much space do we have? Not a lot, so let's just be careful. A, B, mass, velocity. So A has a mass of 4 kg, B has a mass of 2 kg. Let's just double check. A has 4, B has mass 2. Okay. A is moving at a speed of 5, B is moving at a speed of 4. Now after the collision, A and B coalesce, which means now we're going to treat their mass as the combined mass, which is 6. And the question is, what is the speed at which they're going to be moving? Let's call that A meters per second. Okay, since we've used X, we've used Y, let's call this A. So 4 times 5, that's equal to 20. 20 plus 2 times 4, that's equal to 8, is equals to 6A. That gives us the value of A, and what's that equal to? That's equal to 28 upon 6, which I do not recommend that you... Actually, let's not use A actually. A to acceleration ke liye hota hai. Okay, let's use something else. Let's use... क्या use कर सकते हैं? B use कर सकते हैं. C... P तो momentum के लिए हो जाएगा. V कर लेते हैं चलो. Let's just call it V. Okay. So the V of the combined particle is now 14 upon 3 meters per second. ठीक है? Okay. Now. अच्छा बेटा, I'm afraid I'll have to put this guy in timeout now. ठीक है, अब इसी का ही loss है, मैं क्या कर सकता हूँ? Okay, now, what's left is that we now have to find out the total loss of kinetic energy in the system due to the 3 collisions. Okay, How do we find out the loss? We will do final minus initial. So what was the initial kinetic energy? So initially, at the very beginning of the journey, it was just A that had kinetic energy, B was stationary, and C was also stationary. What was the kinetic energy of A? That depends on the speed that it was moving in or moving at, and it was moving at a speed of 10 meters per second. So that means initially, the kinetic energy was only due to A speed, so it's going to be half into 4 into 10 squared. There was no kinetic energy that B possessed. There was no kinetic energy that C possessed. So 4 times 100 is 400. 400 upon 2 is equals to 200 joules. Now, what about the final kinetic energy? Let's have a look at the final kinetic energy. Now, after all the collisions, after the 3 collisions, remember A and B coalesced. Okay, and since they coalesced, we will take their combined mass, which is equal to 6, and the speed at which they were moving after the final collision of A and B. So that's half into 6 into 14 upon 3, the whole thing squared. And don't forget that C was also moving. Okay, what happened to C? When B went on and hit C, C was moving at a speed of 12 meters per second. So that means we have to take into account C's kinetic energy also. So that is half into, what was the mass of C? The mass of C was 1. So half into 1 into 12 squared. Okay, so let's work this out. 1 upon 2 into 6 into 14 upon 3. Loss of kinetic energy or change in kinetic energy is always done this way. Okay, you find out the kinetic energy at the start, you find out the kinetic energy at the end, and you figure out the difference. So the kinetic energy at the end is 412 upon 3. Now what we do is we find out the difference, and obviously there's always going to be a loss, okay? In momentum, when 2 objects collide, there's always a loss in kinetic energy, okay? There's never a gain in kinetic energy, it makes no sense. So to find out the loss, okay, you can do it either way. You can do 412 minus upon 3 minus 200, or the other way around. But just remember, since the question is asking you to find out the loss is not stated with a negative sign. So we get minus 188 upon 3 joules. But since we're talking about the loss, we will simply say 188 upon 3. That's your answer. ठीक हो गया? मजा आया? No, it's not final equals to initial, guys. It's not final equals to initial. ये तो आप लोग, ये तो you're talking about some other, you're talking about work energy power. Okay, to find out the loss in kinetic energy, you will have to take the difference. Can we use the energy method here? No, the energy method doesn't work over here. There is no work done by driving force. There is no work done by energy method. काम तो करेगा, but it makes no sense. Energy method काम तो करेगा, but it makes no sense because you're just going to be left with change in kinetic energy, and that's it. So when it says change in kinetic energy, just find out the change in kinetic energy. That's it. S1 beta, I will start from tomorrow. Don't worry. ठीक है. अच्छा, now let's do this question. ठीक है, मुझे ज़रा 2 minute दें. I'm gonna go grab some water. In the meantime, if you guys want to attempt this question, go ahead. What would we do if B was moving in the other direction? You would take the velocity as negative, and it won't make a difference because energy would still be positive. Even if B was moving in the opposite direction, you will take the velocity as negative, but velocity is something in the formula you have to square it anyway. So the energy becomes positive. ठीक है? So is work energy power in... I'm not too sure about edXL guy. आपका subject है बेटा, आपको पता होना चाहिए. I don't teach. I have taught edXL, but I haven't taught mechanics of edXL, so I don't know. It's best you look at the syllabus and decide for yourself. Okay, so इसको solve करें. मैं further math? नहीं, I don't teach further math. If by FM you mean further math, then no, I don't do further math. अच्छा guys, solve this. Give me 2 minutes. I'm just gonna go grab some water. Okay. Let's see. Anyone who has solved this question? V is 1.11. I don't think so. It's 1.11. But chalo, let's solve. So a particle P of mass 0.3 kg is lying on a smooth plane inclined at an angle 30 degrees to the horizontal. So that means 4.5 sounds right. Yeah, 4.5 is the correct answer. So this plane is smooth. Achha, one thing that I would like to mention over here is this. Whatever information is written in the question, okay, that information applies to every part of the question. So if you're told that this plane is smooth in the question, that means no matter what part that follows, this plane remains smooth. Okay. Is released from rest. So you can see is released from rest. That means the initial velocity will be equal to 0. Achha, even though the plane is smooth, does that mean that the speed will remain constant? No. If the plane is smooth and it's inclined, it will accelerate. The only time when the speed is constant is when you have a horizontal smooth plane. Okay. P slides down the plane for a distance of 2.5 and then reaches a horizontal plane. There is no change in speed when P reaches the horizontal plane. That means the second it moves from the inclined plane to the horizontal plane, okay, or you can say the declined plane from P's perspective, it's decline. So from the declined plane to the horizontal plane, there is no instantaneous change in speed. Okay, you'll often find this written in questions. A particle Q of mass 0.2 kg lies at rest on the horizontal plane 1.5 meters from the end of the inclined plane. Okay, so here and here. P collides directly with Q. It is given that the horizontal plane is smooth. So that means it's only in this part that the horizontal plane is also smooth, and that after the collision, P continues moving in the same direction with speed 2 meters per second. Okay, find the speed of Q after the collision. So first of all, let's understand the whole journey of this particle. Okay, so you can see that P will first go from here to here, and then as soon as it reaches the horizontal plane, then whatever speed it reaches the horizontal plane with, it will carry on with that speed only. Okay, so I repeat, as long as it's going down the plane, it will keep accelerating, but the second it reaches the horizontal plane, and whatever speed at which it reaches the horizontal plane, it is going to continue with that speed only. Okay, it's not going to accelerate on the horizontal plane, but it will accelerate for as long as it's going down the plane. Okay, and what is the force due to which it will accelerate? Question for you guys. What's the force due to which it will accelerate? This is a question from May-June 2020, paper 4, variant 1. The force due to which it will accelerate is its own weight component. Okay. The force due to which it will accelerate is its own weight component. Achha. Now let's resolve the forces one by one. No need to rush into these questions, okay? So this angle is 30 degrees. Therefore, this angle will also be equal to 30 degrees. The weight will be 3 newtons. So that means the component of weight perpendicular to the plane will be 3 sine 30. Okay. Okay. Now, 3 sine 30. Remember, for P, this is what we're doing. Okay. So all this stuff that we're doing it for P. So for P, we'll have to use forward minus backward equals to mass times acceleration, which is basically another version of, an elaborate version of F net equals to mass times acceleration. Now, what's the forward force? What's the force making it move forward? Or what's the force that's acting in the direction of motion? Always make double arrows to show the direction in which the object is moving in. That's 3 sine 30. What's the force acting in the opposite direction? No force. The plane is smooth. There's no other external force. Equals to mass times acceleration. That means 0.3 A. So A is equals to 3 sine 30 divided by 0.3, that's equal to 5 meters per second. So 5 meters per second. Now, notice that P starts from rest, okay, which means the initial velocity is equals to 0. The acceleration is 5 meters per second square, and the distance that it travels Okay, the distance of the inclined plane is what? Is 2.5 meters. So the question is, as soon as it reaches here, as soon as it reaches the bottom of the plane, what will be its speed? Can we work that out? Yes, we can. We have the distance that it travels, that's 2.5, and we want to find out its speed at the end of this plane. Okay, so let's work that out. P1 से ज़्यादा easy था. चलें, that's nice, that's nice. Congratulations, Ayan. So 2as equals to v square minus u square. 2as equals to v square minus u square. So 2 times 5 times s, which is 2.5, equals to v square minus 0 squared. 5 आ रहा है. ठीक है, अभी देख लेते हैं. Just a minute. So v is equals to, 5 into 5, that's 25. Square root of it is 5 meters per second. Okay, now, what happens is, now we're dealing with the second part of the story. Okay, so now the second chapter starts. Second chapter mein, P is now at the bottom of the plane and it is now moving towards Q at a speed of 5 meters per second. Okay, while Q is just chilling. Q is at rest. ऐसे ही है? Q lies at rest. Yep, that's correct. Okay, so this is the before scenario. What happens after the collision? After the collision, we are given the speed of P, but we're not given the speed of Q. So that means after the collision, P continues to move in the same direction at a speed of 2 meters per second, whereas what's the deal with Q? We don't know. So let's call that X. Okay. So once again, let's make the before table, the after table. Not AB. This time it's P, this time and Q. P, Q, mass, velocity. Now what's the mass of P? The mass of P is 0.3. What's the mass of Q? The mass of Q is 0.2. Okay. P right before the collision has velocity 5. Q is stationary. P right after the collision has velocity, mass is the same, 0.3 and 0.2. Right before the collision has velocity 2. Q on the other hand has velocity x. So law of conservation of momentum says momentum before equals to momentum after. 5 into 0.3 is 15. 15 divided by 10, that's 1.5 plus 0 is equals to 0.6 plus 0.2x. So I'm just going to write down the value of x directly. So that's 1.5 minus 0.6, that is 0.9. So 9 upon 2 or 4.5. 4.5 meter per second. That is the velocity of Q after the collision. ठीक हो गया? So why don't we take S as 1.25? Why would I take S as 1.25? I'm focusing on this part of the journey. So why would I take it as 1.25? Does not make sense. Energy method. Yeah, we could use energy method here. We could have used energy method over here also. Because there is no work done by driving force, there is no work done by, it's basically change in potential equals to change in kinetic. Yeah, we could have used energy method also. Good idea. Khair. But energy method only to find out the velocity of P when it reaches the bottom of the plane. Okay, that's the only part that we could have used the energy method for. Okay. So which speed is 5? 5 is the speed of P as soon as it reaches the bottom of the plane. Okay, 5 is the speed of P as soon as it reaches the bottom of the plane. Okay, and as soon as it reaches the bottom of the plane, it will continue with that speed. Why? Because it's a smooth plane. Acha, what's going to happen in part B? I can anticipate that in part B, the plane is going to be rough. Yep, that's correct. So the horizontal plane is now rough. And that when P and Q collide, they coalesce and move with speed 1.2. Zainab, I've already done plenty of questions yesterday of connected particles. If that's what you want, you can watch yesterday's stream. And then when P and Q collide, they coalesce and move at a speed of 1.2 meters per second. If they wouldn't have said same direction, can we assume it would be traveling in the opposite direction? It's possible, but in scenarios like that, the question says find the two possible values. Okay, in scenarios like this, the question will always say two possible values. We'll do a question where we don't know which direction and we have to consider two possibilities. Okay, so let's see what is the situation that we're in now. So now it's the same situation up until this point. Okay, so up until this point, everything is the same. Why? Because this plane is still smooth. So that means P enters this horizontal plane, and it enters this horizontal plane at a speed of 5. That part of the story remains the same. So that means this horizontal plane, which is now rough, has P moving horizontally with a speed of 5 meters per second. So P is now moving horizontally at a speed of 5 meters per second. Okay. And it is basically going towards Q. Okay, it's basically going towards Q. All right. And the distance is 1.5 meters. Okay, 1.5 meters. All right. Now, अब note the question says that when the plane is rough, they coalesce and they basically move with a combined speed of 1.2 meters per second. Okay, and what we're supposed to do is we're supposed to find out, and if you think about it, what's not given is the speed of P right before the collision. Tell me, considering that the plane is rough, will the speed of P be the same or will it be different? Hang on, let me just do it again. So this is the situation that we are in now. So notice that at the start of the horizontal plane, when we have P over here, okay, it is moving at a speed of 5 meters per second. Okay, it is moving at a speed of 5 meters per second. And bearing in mind that this is a rough plane. So when it reaches Q, will it have the same speed or a different speed? Question for you guys. When it reaches Q, will it have the same speed or will it have a different speed? Velocity of P right before collision. I'm not talking about the velocity of P and Q after the collision, because we know that. We know that velocity of P and Q after the collision, after this collision, they coalesce and they both move with the speed of 1.2 meters per second. Okay, so that part is straightforward. But my question to you is different. It will be different. It will be less. Okay, it will be less. Now, what's the answer? Hold on to that. Okay, I don't know what the answer is, but it will be different. That's the main question. The main question is that velocity of P right before collision will not be equal to 5. It will be different. Okay. Now, let's look at the before scenario and let's look at the after scenario. So this is before and this is after. So we have P and Q, we have mass and we have velocity. What's the mass of P? The mass of P is 0.3. What's the mass of Q? 0.2. Let's just double check. Yeah, 0.3 and 0.2. Okay. Now, after they collide, they coalesce, which means as far as the mass is concerned, we'll have to take the combined mass. And as far as the velocity is concerned, that's given in the question, and that's 1.2. Now, what is the velocity of P right before the collision? We don't know. And what is the velocity of Q right before the collision? That's equal to 0. Okay, why is the velocity of P not the same as initially when it reached the horizontal plane? Why is it that its velocity will not remain constant as it's moving on this horizontal plane? Because it is rough. Okay, why? Because it is rough. With the given information, this is what we can find. Now, you may be wondering, why am I figuring this out to begin with? Well, you'll find out. You'll find out. So 0.3 times Vp plus 0 is equals to 0.5 times 1.2, which is equal to 0.6. Yeah. Which means the velocity of P right before the collision is equals to 2 meters per second. So, okay, now what is this? This is basically, you can call it the velocity or speed of P right before collision. And does it make sense? Make sure that you make sense of your answer, okay? You're not doom solving. Does it make sense for a particle to be moving on a rough plane starting with a speed of 5 and then after traveling a certain distance, and we know what that distance is actually, we know that distance is 1.5. Does it make sense that it starts moving on this rough plane at a speed of 5 meters per second, and after moving a distance of 1.5 meters, its velocity has been brought down to 2 meters per second? Does that logically make sense? Yes, it does. Why? Because the plane is rough, so as it moves, it should technically slow down. Okay? It makes total sense. Now, what can we do with the help of this information? what can we do with the help of this information? We can find out the deceleration. Okay, notice that as far as P on the rough plane is concerned, here's what we know about it. We know that its initial velocity is equals to 5. We know that its final velocity is equals to 2. We know that the distance that it moves is 1.5. And we don't know the acceleration. अच्छा, अब सवाल ये है कि why are we finding out the acceleration to begin with? Why do we want the acceleration? So notice that here is P. It's moving in this direction. Okay. And it's moving on a rough plane. And there is no force due to which it's moving in the direction that it's moving in. But there is a force that's acting in the opposite direction. There is a force that's acting in the opposite direction, and that's the frictional force. Okay? Achha, if I use the formula forward minus backward equals to mass times acceleration, I run into a problem. Forward minus backward equals to mass times acceleration. There is no forward force. The backward force is frictional force, which is equal to mass. What's the mass? The mass of P is 0.3. And what's the acceleration? We don't have the acceleration. So since we don't have the acceleration, that is why we're doing what we're doing. Okay? Now, let's see what's next. So with the help of this, we can find out the acceleration. We can use 2as equals to v square minus u square, and we can find out the acceleration. So 2as, which means 2a times 1.5 equals to v square, which is 2 squared, minus u squared, which is 5 squared. Now, what will the acceleration be equal to? Should it be positive or should it be negative? Question for you guys. Should the answer be positive or should the answer be negative? Let's see how many of you are paying attention and how many of you are doom solving. The value of a that I am going to get, it should be negative. It should be negative. And what is that? That's minus 7 meter per second square. Okay. Why won't the forward force be 3 sine 30? Beta, it's moving on a horizontal plane now. Okay, it's moving on a horizontal plane. So why would the forward force be 3 sine 20? The forward force was 3 sine 20 for as long as it was moving on an inclined plane. Okay, its weight component was acting downwards. Now that it's on a horizontal plane, there will be no forward force. Okay, because there's no force that's pulling it. So we have the acceleration. Now notice that minus times the frictional force is equals to 0.3a, correct? So minus times the frictional force is equals to 0.3 times a, which is equal to minus 7, which gives us the frictional force. And what's that equal to? That's equal to 2.1 Newton. That's equal to 2.1 Newton. Now, the question is, what's the frictional force equal to? It's equal to mu times r. Now, what's r going to be equal to? That's interesting. Okay, we haven't really thought about r. Now, notice that P has a mass of 0.3. That means its weight will be acting downwards of 3 Newton, which means that its normal reaction force will be acting in the opposite direction of r Newton. That means r must be equal to 3 also. So mu times 3 is equals to 2.1. And now you can find out the value of mu. What's that equal to? That's equal to 2.1 divided by 3, which is equal to 0.7. And that's the answer. Maza aaya? This was fun, no? Why forward force equals to 0? Why not? Is there a force that's making it move towards Q? Is there a pulling force? Is there a pushing force? No, there isn't. Mensuration आया था 25 marks का. ठीक तो हो बेटा. Pretty sure ऐसा तो कुछ नहीं आया होगा. अच्छा, I'll give you guys a summary. I will give you guys a summary. Now pay attention. देखो, majority of the questions जो आप लोग मुझसे पूछ रहे हो ना, किसी ने पूछा कि वो forward force 3 sine 30 क्यों नहीं होगी, किसी ने पूछा कि there was another question. You guys will find the answer to your question if you just read the question. ठीक है? Okay, now. So here we are. In the second part, the horizontal plane is no longer smooth. It is now rough. Okay? The horizontal plane is now rough. Which means that whatever velocity, whatever speed P enters the horizontal plane at, it will not be the same. It will not be constant. Okay, it will be different. It will slow down because it's moving on a rough plane. मैं दोबारा बता रहा हूँ. अच्छा, how did I figure out this 5 meters per second? So notice that the exit speed is now the entrance speed. Think of it this way. The speed at which it exits the inclined plane is the speed at which it enters the horizontal plane. Okay, so for example, over here, there is no change in speed when P reaches the horizontal plane. So that means whatever speed at which it leaves the inclined plane, it starts with that speed on the horizontal plane. Okay? Now, that's how I know the initial speed is equals to 5. Now, the thing is, since it's on a rough plane, obviously the velocity right before collision will not remain 5. It will be different. Okay? But the surface won't it affect the speed? It will affect, that's why it's going to slow down. Okay? ये तो देखो, ये तो पहुंचने के बाद 5 है ना? अब जैसे जैसे रफ सरफेस पे चलेगा तो स्लो डाउन हो जाएगा. ऐसे इंस्टेंटली तो चेंज नहीं हो जाएगी ना. उसके लिए अगेन बेटा सवाल पढ़ो. देयर इज़ नो चेंज इन स्पीड व्हेन पी रीचेस द हॉरिजॉन्टल प्लेन. ठीक है, तो एग्जैक्टली जो चीज़ आप कह रहे हो उसी का जवाब सवाल में है. सो रीड द क्वेश्चन. नाउ वी आर गिवन द speed of the combined particles right after the collision. So if you have the mass after collision, if you have the speed after the collision, that means what you can do is you can find out the speed right before the collision. That means this is the point when P starts to move on the rough plane, and right before it reaches Q, we can find out the speed by using law of conservation of momentum. So the mass of P into its velocity right before collision equals to the mass of Q plus the mass of Q into its velocity right before the collision is equal to the mass into velocity after collision. So with the help of this, we get the velocity of P, which is 2 meters per second, and that is the velocity of P right before the collision. Okay, right before the collision. So this means that as it moved 1.5 meters, it decelerated. The initial velocity was 5, the final velocity is 2, the distance is 1.5, and you can see that we have now found its deceleration. Now, why do we want its deceleration? Because let's look at the forces. So there's forward minus backward equals to mass times acceleration. There is no forward force. So to answer your question, if there was a forward force, you would include that. Simple as that. Okay. Forward force is 0. The only force that's acting in the opposite direction is the frictional force, which is equal to mass times acceleration. Now, before I can find out the frictional force, I need the acceleration. So what is the acceleration? The acceleration is -7. And now we have the frictional force, which is 2.1, which is equal to mu times r. R will be equal to the weight since there is no external force, and we can then find mu, which is 0.7. And that's it. ठीक है? अच्छा, अब एक काम करते हैं. Let's level up a little and let's do some complex questions. Let's do this one. Yeah, let's do this one. This is from February, March 2023, paper 4, variant 2. So question number 9 of the worksheet whenever possible. Question number 9. Let me have a look at question number 9. Okay. 9 is interesting. We can look into question number 9. पहले ये वाला ना कर लें. Yeah, there are obviously more complex questions. ठीक है, ये vertical वाले ज़रा end के लिए छोड़ देते हैं. पहले ये करते हैं. This is February, March 2023, paper 4, variant 2. Okay, let's see what it says. The diagram shows a smooth track which lies in a vertical plane. अच्छा, अब ये जो है ना, this is basically a difficult momentum question. Why? Because it's a multi-stage problem. Okay, it's a multi-stage problem. Okay, a good example of a multi-stage problem. Let's see what it says. So full syllabus भी करवाएंगे, बिल्कुल करवाएंगे. Full syllabus इंशाल्लाह कब कराएंगे? Full syllabus at 7:15. So stay tuned. The diagram shows a smooth track which lies in a vertical plane. The section AB is a quarter circle of radius 1.8 with center O. The section BC is a horizontal straight line of length 7.0 meters and OB is perpendicular to BC. The section CFE is a straight line inclined at an angle of theta to the above the horizontal. a particle P of mass 0.5 kg is released from rest at A. So here there is a particle P which is released from rest at A. Okay. Particle P collides with a particle Q of mass 0.1 kg which is at rest at B. So that means here the particle P collides with particle Q which is at rest also. Immediately after the collision, the speed of P is 4 in the direction of BC. You should assume that P is moving horizontally when it collides with Q. Okay, so that means we don't have to worry about वो क्या बोलते हैं उसको एंगुलर वेलोसिटी. ठीक है, कुछ ओवर स्मार्ट लोग होंगे वो एंगुलर वेलोसिटी के बारे में सोचना शुरू कर देंगे. सो दैट्स व्हाई इट्स सेइंग कि P is moving horizontally. Okay, so this is the situation. This is where P is, and then right after the collision, here it is. Right before collision, here it is. ठीक है. अच्छा, please confirm what, sir? Please confirm we'll be doing AD Maths. Yeah, but I will be doing AD Maths stream. Take it easy. Now, what's happening from A to B? We can see we can't use, so one thing that we can't do is we can't break down the weight component of P. Why? Because this is not a straight line. Okay. And why do you think we're given this 1.8 meters? Something to think about. Why do you think that we are given this 1.8 meters? Notice that as P moves from A to B, it loses a height of 1.8 meters. Okay, it loses a height of 1.8 meters. Okay, so yes, we can use the energy method. Okay, and the energy method will just simplify to change in potential equals to change in kinetic energy. Okay, the energy method will quite simply simplify to change in potential energy equals to change in potential energy. Change in potential equals to change in kinetic. Okay, so the energy method says that the total work done is equals to change in potential energy plus change in kinetic energy. Now bear in mind that there will be a loss in potential energy and there will be a gain in kinetic energy. Okay? Now as far as the total work done is concerned, total work done basically means by minus a gain. So what if we do it with arc length? Arc length, what are you going to do with the arc length? You still can't figure out the acceleration. You still can't figure out the acceleration of this particle. Because for us to be able to figure out the acceleration of this particle, we have to break it down into horizontal and vertical components, and for that the plane has to be a straight line, which it is, in which it isn't. So there is no driving force, there is no resistive force. Okay, which means change in potential energy, and it will be a loss in potential energy. That will be mgh, that's 0.5 into 10 into 1.8. And this is equal to a gain in kinetic energy. So plus the change in kinetic energy, which is equal to half into 0.5 into v square. Okay. So what we're looking at is this. 0.5 into 10 into 1.8, that's equal to 9. So 9 is equals to 0.25 v square. So 9 divided by 0.25, that's 36. V square is equals to 36, which means V is equals to 6 meters per second. Now what is this? This is basically the speed of P before collision. This is the speed of P before collision. Okay, the speed of P just before the collision is 6 meters per second. It's not 3, okay, it's 6. Now what happens after that is this. So here's P and here is Q. Just before the collision, okay, just before P collides with Q, P is moving at a speed of 6 meters per second. Okay, so this is the before situation. And right after the collision, what happens is given to us in the question. Immediately after the collision, the speed of P is 4 in the direction BC, and we have to show that immediately after the collision, the speed of Q is 10 meters per second. So that means right after the collision, P's speed drops down to 4. So P is now moving in the same direction, but this time it's now moving at a direction of 4 meters per second. And we have to find out the velocity of Q, or the speed of Q after the collision, and we have to show that it's equal to 10. Okay, so here is the before table, here is the after table. Here is P, here's Q, here's the mass, here's the velocity. Here we go. Now what's the mass of P before the collision? The mass remains the same, that's 0.5. And the mass of Q after the collision, before the collision is 0.1. And they don't coalesce or anything, so it remains the same, 0.5, 0.1. Okay, now the speed of P right before the collision is 6, the speed of Q is 0, the speed of P right after the collision is 4, and we have to find out the speed of Q right after the collision. We have to show, in fact, that it's equal to 10. So 6 into 0.5 is 3. 3 plus 0 is equals to 2 plus 0.1 VQ. So 3 minus 2 is 1. So 0.1 times VQ is equals to 1, which means the velocity of Q right after the collision is 1 divided by 0.1, which is 10 meters per second. And there you go. In the end, write the statement for good measure, and that is hence proved, yeah, hence shown. There we go. Okay. All right. Now, work done by... Yeah, there is no external force because there is no force that's acting in the direction the object is moving in, and there is no force acting in the opposite direction. Okay guys, I'm here till 7:15. I'll try to make sure that I'll solve as many questions as possible. So just take it easy. Okay. Then when Q reaches C, it collides with a particle R of mass 0.4 kg, which is at rest at C. All right. The two particles coalesce. So let's underline that. That's important, that Q collides with another particle and they coalesce. The combined particle comes instantaneously to rest at F. You should assume that there is no instantaneous change in speed as the combined particle leaves C, nor when it passes through C again as it returns down the slope. Okay. Given that the distance CF is 0.4, find the value of theta. There is a lot that's going on over here. Okay. There is a lot that's going on over here. So basically, एक काम ये करते हैं. Let's delete this. Let's take a screenshot of this so we don't have to do back and forth. Let's bring this back. Okay. First of all, let's spend some time to understand the question. See, these are the kind of questions which if you do get in the exam, make sure you leave them for the very end. Okay, do not waste your time trying to solve this first. Leave them for the very end. So here's what happens. P and Q have collided. Okay, and we now know that Q is moving towards C at a speed of 10 meters per second. Correct? Okay, now, then what happens? It collides with another particle, which is R, and that particle has mass 0.4 and which is at rest at C. So this is basically what's going on here. Okay. The combined particle come instantaneously to instantaneously to rest at F. You should assume that there is no instantaneous change in speed as the combined particle leaves C. अच्छा, अब उसके बाद हो क्या रहा है? पहले तो एक काम करते हैं. First of all, let's find out the speed of the combined particle right after the collision. Okay, so what we don't know is, we do know that when Q collides with R, it collides with a speed of 10 meters per second. The question is, what is the speed of these combined particles after the collision? We don't have that. Correct? Let's read the question again. When Q reaches C, it collides with particle R, which is at rest. The two particles coalesce. Now we're given that they coalesce, but the question is, what's the speed after collision? We don't have that. We can work that out with the help of momentum. The combined particle comes instantaneously to rest at F. So that means Q and R combined will go up and then will come back down after they come to rest. ठीक है? अच्छा, अब ये वाली कहानी पे हम बाद में focus करेंगे. First, let's find out the speed at which the speed of P and Q after the speed of Q and R after the collision. Okay, so first let's do that. Let me write it down because there's so much going on. Let's write it down. First, find out the speed of Q and Q को capital में लिख लेते हैं. Q and R right after collision. Let's do that. Okay, now अच्छा अब मैं थक गया हूँ ये बिफोर आफ्टर बना के, ठीक है, अब इसको डायरेक्टली कर लेते हैं. सो हियर इज़ द बिफोर सिनारियो, हियर इज़ द आफ्टर सिनारियो. आई होप वी हैव इनफ स्पेस लेफ्ट. या वी डू. So we have P, we have, no wait, we don't have PQ anymore. We have Q, we have R, we have Q, we have R, we have their mass, we have their velocity. So the mass of Q is the mass of Q is 0.1. Okay, and its velocity is 10. The mass of R is 0.4 and it's at rest, so its velocity is 0. Now, right after the collision, these two coalesce, which means their combined mass will be taken, which is 0.5. Okay, and what is the velocity? We don't know. Let's work that out. So this becomes 1 plus 0 is equals to 0.5 v, which means right after the collision, the combined velocity is equals to 1 divided by 0.5, which is 2 meters per second. ठीक है, यहाँ तक सबको समझ आया? O level P2 exam was easy. Chale, that's nice. Paper 4 was so good. Chale, I'm glad to hear that. Did this question yesterday. Part C is confusing. I'll come to part C. ठीक है, I'll come to part C. सर फिर इसी सवाल की टेंशन चलती रहेगी माइंड में, ये करना है. लेकिन बेटा अब अगर आप इसको शुरू में कर लोगे और आप if let's say you're unable to solve, then you're just gonna mess up the entire paper. Okay, so I hope we're clear about that. Achha, what's next? Next is that we have to find out, we're given that CF is equals to 0.4 and what we have to do is we have to find out theta. ठीक है, क्या निकालना है हमें? हमें theta निकालना है. अच्छा, अब कैसे निकालेंगे theta? Pay attention. What is the value of theta? Let's find out. Let's find out. So here's what's going on. So this is C and this is F, okay? And CF is given to us to be 0.4, okay? CF is given to us as 0.4. Now, let's analyze the journey of these two combined particles, okay? Let's analyze the journey of these two combined particles. As soon as it reaches C, okay, as soon as the particles collide at C, their initial velocity is equal to what? Their initial velocity is equals to 2 meters per second. Now, if they come to rest at F, that means their final velocity must be equal to what? Their final velocity must be equal to 0. ठीक है? अच्छा, what is this plane? Is this plane rough or is this plane smooth? This plane is... Okay, this entire track is smooth. Brilliant. This entire track is smooth, okay? So what does that mean? Since the entire track is smooth, that means the potential energy is gained at a loss of kinetic energy, okay? And there is no external force, okay? There is no external force. So what would the height be equal to? The height would be equal to 0.4 sine theta. Height, we can use Newton's second law and we can also use the energy method. Which method do you guys want to use? Do you guys want to use the Newton's second law or the energy method? I think I know the answer. You guys will probably say both. So let's do it both ways. ठीक है, इसको मैं दोनों तरीकों से आप लोगों को करके दिखा देता हूँ. ठीक है, first let's use the energy method. Let's use the energy method. Now, if I use the energy method, okay, that is total work done is equals to change in potential energy plus the change in kinetic energy. Now total work done will be 0 because there is no driving force, there is no resistive force. So total work done is equals to 0. Sir, can I ask you in which video? Beta, I don't know what were you doing yesterday, but yesterday I did a detailed stream on work energy power, so make sure to check that out. So total work done is equals to 0. Okay, why? Because there is no driving force, there is no resistive force. The entire plane is smooth. Change in potential energy is going to be a gain in potential energy, and what will that be equal to? The mass of the combined particle is 0.5, acceleration due to gravity is 10, and the height is 0.4 sine theta. Okay, now plus the change in kinetic energy. what is the change in kinetic energy going to be? It's half into 0.5 into the final velocity squared. That means 0 squared minus 2 squared. Okay. What does no instantaneous change mean? No instantaneous change basically means, because you might think as soon as, see, for example, let's say if you're driving a car and as soon as you hit a bridge or the start of the bridge, what happens is the velocity just changes the second you hit the bridge. Okay, the second the front tire hits the inclined part of the bridge, the velocity changes. Okay, in practically, but here that's not the case. That's what it means. Okay. Acha, so here we are. Now let's see, what do we get? 0.5 into 10 into 0.4, that's equal to 2. So 2 sine theta. 2 sine theta. So beta, मैं पहले इसको solve कर लूँ, फिर I'll start looking at your queries, okay? I can't do both at the same time. So 0 is equals to 2 sine theta. Now what is the change in kinetic energy? 1 upon 2 into 0.5 into 0 squared minus 2 squared. That's equal to minus 1. Okay, this leads to the conclusion that sine theta is equals to 1 upon 2, which gives us the value of theta, and that's equal to 30 degrees. Okay. Okay, this is February, March 2023, paper 4, variant 2. Now let's do it the other way, and then I'll take your queries, okay? Because I can see some of you are asking about Newton's second law. So first let me do it this way, then I'll take your queries. Now, notice that what is the component due to which this particle will decelerate? What is the force due to which this particle will decelerate? There is no friction, the entire track is smooth. So the only reason for this particle to decelerate is its own weight component, okay? And its weight will be 5 Newton acting downwards, vertically downwards. And this is theta, since this is theta. So that means the component of weight due to which this will decelerate will be 5 sine theta. Now this is moving up the plane, so double arrow showing the direction in which it's the whole thing is moving in. So this means that if we're going to do forward minus backward equals to mass times acceleration. Now there is no forward force. The backward force is 5 sine theta, and mass times acceleration is equal to, we'll have to figure out the acceleration. If we're using Newton's second law, then we'll have to figure out the acceleration. This is equal to 0.5 a. Okay? The question is, how do we find out the acceleration? So to find out the acceleration, considering that we're using Newton's second law, now we're running out of space. I do not recommend that you use Newton's second law, but let me add an extra page over here. अभी आप लोग ज़रा अपने questions को hold करो, मैं पहले ये पूरा solve कर लूँ, then I'll take your questions. ठीक है? And in the meantime, I would advise you to please read the question carefully, because majority of the questions, the answer to majority of your questions will simply be read the question. क्या सीन है? Okay, so we're now using Newton's second law. ठीक हो गया? अच्छा, अब Newton's second law में, let's just do it again यार. Newton's second law में, we have to see the force due to which it's going to decelerate. And what is that force? That force is its own weight component, which will be 5 Newton is the weight. Okay, why are we taking 5? Because they've combined. So that means its own weight component will be 5 sine theta, due to which it's going to decelerate, and double arrows to show the direction in which the object is moving in. Now please note that u is the speed at which these two particles entered the plane. That's 2 meters per second. Okay, so u is equals to 2. The distance that they move up the plane is 0.4. Given in the question, please don't ask me where I'm getting these values from. So 2 we worked out. 0.4 is given to us. Cf, the distance that they move up the plane. The final velocity is equals to 0. I'll write in bracket Cf so that you guys know what I'm referring to. The final velocity is equals to 0. With the help of this, we can find out what? We can find out the acceleration. Now, will the acceleration be positive or negative? Think to yourself and answer. Obviously, it's going to be negative. Okay, why? Because there is no force that's pulling it up the plane, but there is a force which is acting in the opposite direction. So 2as equals to v square minus u square. And please understand that all of this is not working for one question. This is just an alternative method. Okay, so the method that I'm using now is an alternative method. So 2 times a times s, which is 0.4, equals to 0 squared minus 2 squared. So what is a equal to? A will be equal to minus 2 squared divided by 2 divided by 0.4. That's equal to minus 5. Okay. Now if I use Newton's second law, which is forward minus backward equals to mass times acceleration. What's the forward force? There isn't any. What's the backward force? Its own weight component, which is 5 sine theta, is equals to mass times acceleration. That means 0.5 into minus 5, which leads to the conclusion, I'm going to skip a few steps, you guys are smart enough now to figure this out, which leads to the conclusion that sine theta is equals to 1 upon 2, and take the inverse of half and you will get 30 degrees. And that's it. This is an alternative method. ठीक है, अब इसका part C confusing है, but before we move on to part C, let me see what's going on in the chat and let me see if there are any questions to answer. Okay. Work power energy की stream बेटा हो गई है, आप सो रहे थे क्या? I did a detailed stream of work power energy yesterday. सर अगर sin x equals to 0.8 हो तो हम cos x के लिए आप वो कर लो ना, make a triangle and then figure out cos x, or simply do use the identity sin square theta plus cos square theta equals to 1. Can I write total work done in the exam? Yes, of course. What kind of a question is that? You can write total work done. How do you know the speed at f is 0? क्या लिखा है ये? अब्दुल्ला तारिक, क्या लिखा है ये? So can you solve one question from every topic, every type? नहीं बेटा, I can't do that. ठीक है, I'll do a syllabus run through. ठीक है. So I hope you find the answer to your question, Abdullah. अच्छा. What else? What else? Can't the acceleration be g? Oh भाई, कैसे g होगी? It's moving on a plane. Why would it be equal to g? It's not moving vertically. It's not under free fall. वहीं में g लगा दो यार. थोड़ी अकल भी इस्तेमाल कर लेते हैं, खर्च नहीं हो जाएगी, ठीक है? It doesn't work like money. If you spend it, it doesn't deplete. And it's not like any other resource. Break. अभी पहले इसका part C तो करने बेटा. अभी इसका part C बाकी है. अच्छा मैं ज़रा एक let me do a quick back stretch. Okay. How long is this stream going to be? Well, I know that 7:15 I have to start another stream, so probably before 7:30. Gang, when PQ comes down from F to C, does Amna? ये आपके लिए. This is for you. पढ़ लिया? So please solve May, June. Acha, I'll do that. When have I scheduled my next stream? Is it 7:15 or 7:30? Okay, अच्छा इसको तो continue करते हैं, पहले हम बातों में लगे हैं. Find the distance from B at which P collides with the combined particle. Okay. Now this is the fun part. This is the fun part. So here's what's going on now. Here is what's going on. अब हुआ ये. How much space do we have? Plenty. So guys, now pay attention. ठीक है? So let's look at the question. Find the distance from B at which P combines with the combined particle. find the distance from B at which P collides with the combined particle. अच्छा, अब हुआ ये था, so there was P here and there was Q over here, okay? And right after the collision, P started moving at a speed of, right after the collision, P started moving at a speed of, कहाँ गया? Right after the first collision, P started moving at a speed of 4 meters per second. Okay, don't forget that. Right after the collision, P started moving at a speed of 4 meters per second. Okay, so this was the first part of the story when P and Q collided. Okay, what was the speed of Q right after the collision? When P and Q collided, what was the speed of Q right after the collision? The speed of Q right after the collision was 10 meters per second. Is that correct? That's what we had to show, right? Or maybe that is from the previous question. No, it was 10. Okay, so right after the first collision, when P and Q collided, Q's speed was 10 meters per second. Okay, so Q's speed right after the first collision from B to C is 10 meters per second. Okay, so from B to C, Q is traveling at a speed of 10 meters per second. So the question is, how long did it take? ठीक है, अच्छा देखो पूरे पहले journey समझ लो. Make sure that you understand the entire journey before you figure out what you have to do. अच्छा, I'm not reading the chat right now, so just pay attention. So this is what's going to happen. P comes down the plane, collides with Q. It pushes Q at a speed of 10 meters per second, and P continues to move at a speed of, after the first collision, the speed of P was 4 meters per second. Okay, so as soon as P collides with Q, so P continues to move at a speed of 4 meters per second. Okay, I'll write it down over here so I don't have to do a lot of back and forth. Velocity of P is 4 meters per second after collision. ठीक है, अच्छा अब होगा क्या, गौर से समझना. ठीक है, so once again from the beginning, P को यहाँ से छोड़ा, P comes down the plane, it collides with Q. As soon as P collides with Q, it starts moving at a speed of 4 meters per second. Q starts moving at a speed of 10 meters per second. So Q now goes ahead, it collides with R, and they both become QR. Okay, then what happens is QR will go up, come to rest, QR will come back down, and on the way down there will be particle P somewhere with which they're going to collide. Okay, so I repeat, इसको थोड़ा मैं आगे बना देता हूँ. यहाँ पे P है, okay, this is after the first collision, and यहाँ पे Q है. Okay, so please understand that this is after the first collision, and this happens at point B only. So this is what I'm drawing is not drawn to scale. I'm just drawing to make you understand the entire story. So right after the first collision, this is the situation that we are in. So what you see below is after collision. After collision, P is now moving at a speed of 4 meters per second. Q, on the other hand, is moving at a speed of 10 meters per second. Because the whole thing is understanding the step-by-step, the whole parts of the journey. Solving it becomes easy, but the difficult part is understanding the entire journey. So Q starts moving at a speed of 10 after it collides with P, while P continues to move in the same direction at a speed of 4. Now what does Q do? Q goes and collides with R, and what do? They go up, they come back down. And on the way down, these two particles combined will at some point collide with P, which throughout this time is still moving towards C. Okay, it's still moving in this direction. ठीक है, ये है basically जो इसमें हमें करना है. ठीक है, अच्छा again मैं chat नहीं पढ़ रहा. I want you guys to just pay attention to what we're doing over here. So speed is equals to distance upon time. We're talking about Q right now. Okay, we're talking about Q's journey as it's going from B to C. What is the speed at which it's going? It's going at a speed of 10. What is the distance that it travels? It travels a distance of 7. How long does it take? We know that it will take 7 over 0.10, which is equal to 0.7 seconds. Okay. Now, as soon as Q reaches C, it will go from C to F. So we're talking about Q once again, but this time we're talking about Q's journey from C to F. And since C to F is an inclined plane, it will go up and then it will come back down also. So from C to F and back. From C to F and F to C. Okay? Which means it will go up and then it will come back down. Now, the duration that it will take to go up will be the same as it will take to come back down. Okay? That's kinematics, remember, is symmetrical. Okay? Now the question is, what is the duration that it will take to go up? Let's see. The initial velocity was 2. Okay, remember the initial velocity was 2. The final velocity is 0. The acceleration is -5, and we now have to use this to find out t. Okay, so what formula can we use? We can use v is equals to u plus at. So I repeat, we're now focusing on this part of the journey from C to F. ठीक है, ये E को ignore करें, we're just focusing on the part of the journey from C to F. ठीक है, समझो F यहाँ पे है. So QR goes up, the velocity with which it reaches point C is 2. The final velocity is equals to 0. The deceleration is -5, and we have to find out the time. So 0 is equals to 2 minus 5t, which gives us the value of t, and that is 0.4 seconds. Now, please understand that this is one way. This is 0.4 seconds to go up. What about the time that it will take to come back down? It will take the exact same time to come back down. Okay, you can work it out yourself. When you find out the time that it will take to come back down, the initial velocity will be equal to 0. If you're looking at the downwards journey, the final velocity will be equal to 2. Okay, the acceleration will be equal to 5. You can work it out, and you will get the same time. Okay, that's how kinematics work. It's the motion is symmetrical. Okay, which means that the total time is equals to 0.8 seconds. Okay? So the time to go up and the time to come back down is 0.8 seconds. Okay? So how long has it been? What is now the total time? The total time is equals to 0.7 plus 0.8. And what's that equal to? That's equal to 1.5 seconds. So 0.7 to go from B to C. Okay? And 0.8 to go from C to F and back. Okay, so that's 1.5 seconds. Now the question is, what was P doing for 1.5 seconds? So let me look at the chart now. What was P doing for this 1.5 seconds? It was moving. Okay, it was moving. So throughout this time, P kept moving. Okay, it's not that P was waiting and watching, P kept moving. What is the velocity at which P is moving at? P is moving at a velocity of 4 meters per second. Okay, so now let's focus on P. So P, let's look at P's distance traveled in 1.5 seconds. For P, we're now looking at the distance P has traveled in these 1.5 seconds. So we know that distance is equals to speed into time. The distance is what we want to find out. The speed is 4. It's not going to change because it's a smooth plane. The time is 1.5. So that means the distance that P travels is 4 into 1.5. What's that equal to? That's equal to 6 meters. Okay. Achha, up the final stretch. Now pay attention. Now is the final stretch. So this is what it looks like now. This is point B, this is point C. Okay. अच्छा बेटा ओ लेवल्स वाले, इट्स गुड, आप लोगों का पेपर आसान हुआ. अभी आपसे मैं थोड़ी देर में बात करता हूँ. अभी लेट मी फोकस ऑन ए लेवल स्टूडेंट्स. ठीक है. So this is 7.0 meters. Okay. P has already traveled 6 meters. So this is where P is. It has already traveled 6 meters. And this is where the combined particle is at. This is where QR is at. That means if P has already traveled 6 meters, that means what is the distance apart? The distance apart is 1 meter. Now they are just 1 meter away from each other. Achha, P is moving towards QR and QR is moving towards P. Now, the question is, what is the speed at which P is moving at? 4 meters per second. What is the speed at which QR is going to move at? Question for you guys. What will be the speed of QR? What will be the speed of the combined unit? What's the rule on units? Beta, you're not supposed to write down the units. If you're asking for M1, you're not supposed to write down the units, okay? So what will be the speed of QR, guys? Let's see how much invested you are into this question. 2, that's correct. It will be 2. Okay? It will be 2. Why? Because read the question. Kahan gaya sawal? Yeah. You should assume that there is no instantaneous change in P as the combined particle leaves C, nor when it passes through C on the return down slope. Okay, so what can we do over here? We know that the speed is constant, so that means the formula that we're going to use is speed is equals to distance upon time. And since we want to find out what I forgot nikalna kya hai. We want to find out the distance from B at which P collides with the combined particle. Okay, so since I want the distance will be equal to speed into time. Correct? The distance will be equal to speed into. No, wait a minute. I want the time. Yeah, I want the time. So since you want to find out how long will it take for these two particles to collide, time is equals to distance upon speed. Up the question is, what distance are we going to take and what speed are we going to take? So when we're talking about distance, we're going to take the distance apart. We are going to take the distance apart. And what about the speed? Since they're both traveling in the opposite direction, we will take the combined speed. We will now take the combined speed. So they are 1 meter apart. The combined speed will be 4 plus 2. So that means the time for the collision to occur is equals to, 4 plus 2, not 4 plus 6, 4 plus 2. So that means the time for collision to occur is 1 upon 6 seconds. Okay? So this means that P and QR will collide with each other after 1 upon 6 seconds. Achha, the question is, okay, what is the distance traveled? The question is, what is the, you can do it that way also. You can do SP plus SQ equals to 1, same thing. Okay, you can do the distance that P travels plus the distance that Q travels is equals to 1. Why are we taking their combined speed? We're taking their combined speed because they're traveling in the opposite direction. Okay. All right, now let's look at the distance that P has traveled. So the distance that P has traveled in 1 upon 6 seconds will be equal to speed into time. What is the speed? The speed is 4. What is the time? The time is 1 upon 6, which means the distance that it has traveled is 2 upon 3 meters. Okay. Now, this means that P collides with QR after 1 upon 6 seconds, and in that time, it has traveled a further distance of 2 upon 3 meters. Which means what will be its distance from B? Let's write that down. So the distance from B is equals to 6 meters, which it traveled while Q was going from B to C, then it went up the plane, then it came down the plane, and then an additional 2 upon 3, which means the final answer is 6 whole 2 upon 3 meters. This is the final answer. Sir, is it because velocity of QR is minus 2? So when we do 4 minus minus 2 becomes the sum. Yeah, but dekho, jab bhi do objects, yaad rakho, when two objects are traveling in the opposite direction and we are talking about constant speed, we take the combined speed. When two objects are traveling in the same direction and we have to find out how long will it take to catch, we take the difference of the speed. That's what we do. Okay? Because we're not considering velocity, we're using speed equals to distance upon time. Why are we using speed equals to distance upon time? Because the speed is constant. That is why. Okay, because the speed is constant. So we're not using that formula V equals to U plus AT. Okay, why are we not using that formula? Why did we only use that formula for this part of the journey? Because here the speed was not constant. For p, as long as it's moving on this, any object that is moving on a horizontal surface, horizontal smooth surface, the speed will be constant. That is why we're going to use speed equals to distance upon time. ठीक है? अच्छा, अब मैं आप लोगों को इसकी एक समरी दे देता हूँ. फिर we will, I think it's safe to take a break. सेम डायरेक्शन में सम नहीं सेम डायरेक्शन में सम नहीं लेते, सम ऑलवेज ऑपोजिट डायरेक्शन में लेते हैं. थिंक ऑफ इट लॉजिकली. इफ दे आर बोथ ट्रैवलिंग इन द ऑपोजिट डायरेक्शन, देन दैट मीन्स द डिस्टेंस बिटवीन देम इज डिक्रीजिंग एट a higher rate. That's because they're traveling in the opposite direction. That's why we combine the speed. ठीक है? अगर if let's say you're running towards your friend and your friend is running towards you, compare that with you chasing after your friend. कम टाइम किस में लगेगा? कम टाइम लगेगा when you're both running towards each other. Okay, whereas if you're chasing someone, it will take longer. So that is because when two objects are moving in the opposite direction, we combine their speeds. Okay, whereas if they're running in the same direction, they're moving in the same direction, we take the difference of their speeds. ठीक है? So अच्छा, अब मैं एक दो सवाल और हैं जो मैं करूँगा. ठीक है, आई कैन सी कि आप लोगों के काफ़ी सारी रिक्वेस्ट्स हैं. एक मैं ये सवाल करूँगा, दिस इज़ लाइक द मदर ऑफ ऑल मोमेंटम क्वेश्चंस. ये एग्जामिनर ने भी बनाने के बाद उसको ख्याल आया था कि इसने कितना मुश्किल सवाल बना दिया. ठीक है, सो देयर इज़ दिस वन एंड देयर इज़ वन मोर क्वेश्चन विच आई वुड लाइक टू सॉल्व एंड दैट्स दिस. सो 24 and 25 ये दो सवाल मैं और करूँगा. 25 वैसे काफ़ी डीमोटिवेटिंग सवाल है, लेट मी टेल यू दैट. सो आई थिंक आई विल डू 25 फर्स्ट. Why? Because the examiner just didn't realize what they were doing, and they did allow the opposite approach also. Okay, because the majority of the students did it wrong, so उन्होंने कहा कि चलो हम wrong को भी सही consider कर लेते हैं. ठीक है? अच्छा, और maybe I'll do one question where the objects are moving vertically. ठीक है? I want you to do question 24. ठीक है, तो you're lucky. I will do question. I'm going to do 3 questions now because I need to do a syllabus run through also. If you guys want me to compromise that, then we can do more questions, but I doubt you'd want that. So I'm going to do question number 19. I'm going to do question number 24, and I'm going to do question number 25. ठीक है, and the order in which I'll do them is 25, then I'll do 24, and then I'll do question number 19, and then we're done. ठीक है, अब हम एक लेते हैं नमाज ब्रेक. 5:50 हो रहे हैं. लेट्स कम बैक एट 6. क्या ख्याल है बेटा? सर डिडंट सर जैन सॉल्व February March 2026 पेपर? सो इफ ही इज डन इट तो उनकी वीडियो देख लो ना. आई थिंक ही जस्ट सॉल्व द Feb March 2026 पेपर. डिड ही? आई थिंक आई सॉ हिज स्टोरी. He did, right? हाँ, तो just watch his story. I mean, वो उनकी वीडियो देख लो. ठीक है. He was supposed to, but he didn't. अच्छा, तो February March की yeah, the syllabus run through will be live. It will be at 7. अच्छा, अभी एक काम करते हैं. Let's not waste more time. Let's take a break. We'll reconnect at around 6ish. ठीक है? We'll reconnect at around 6ish. Okay? Okay guys, here we are. अच्छा, टाइम हमारे पास है शॉर्ट, ठीक है, और क्वेश्चंस हमने करने हैं 3. सो लेट्स जस्ट बिगिन. ठीक है, 23. So I'm going to do 25, 24. अच्छा, 23 भी वैसे इम्पोर्टेंट तो है. ठीक है, तो एक काम करते हैं, let's not do question number 19, let's instead do 23. So 25, 24 and 23. ठीक है, let's do that. Alright, let's begin with question number 25. अच्छा, 25 एक काम करते हैं 25 को, can you push the syllabus run through your back in terms of timing? Yeah, 25 को ना ज़रा बैक बर्नर पे डालते हैं. Why am I saying let's put question number 25? वैसे I think I've solved question number 25 in my last momentum stream. ठीक है, that is why. And the reason why I'm delaying question number 25 is because it's just ridiculously difficult. Okay. Question 25 was made by Sir Ahmed Bilal. Really? अच्छा, खैर. So 25 एक ridiculously difficult question है, इतना difficult that they actually accepted the wrong way of solving it. ठीक है. So let's do question number 24. Let's do question number 24. You said the same word about this question. Yeah, because that's how it is, I'm afraid. Okay, now question number 24 कर रहे हैं हम. Pay attention. 3 particles A, B and C of masses 5 kg, 1 kg and 2 kg respectively lie at rest in that order on a straight, smooth, horizontal track. X, Y, Z. Initially A is at X, B is at Y and C is at Z. Particle A is projected towards B with speed of 6 meters per second, and at the same instant C is projected towards B with speed of V meters per second. In the subsequent motion, A collides and coalesces with B to form particle D. Particle D then collides. Okay, so I was just doom reading the question. Let me just read it again. 3 particles A, B and C of masses 5 kg, 1 kg and 2 kg respectively lie at rest in that order on a straight, smooth, horizontal track, X, Y, Z. Okay, initially A is at X, B is at Y and C is at Z. Particle A is projected towards B with a speed of 6. At the same instant, C is projected towards B with a speed of V. In the subsequent motion, A collides and coalesces with B to form particle D. Particle D then collides and coalesces with C to form particle E, and E moves towards C. Okay, now there is a lot that is going on here. And what happened to my black color? Yeah. So here is the situation that we're in. So we have 3 particles. एक, सर मेरी सांस निकल गई थी ये क्वेश्चन. हाँ, ये भी अजीब सवाल है वैसे. इतना मुश्किल नहीं है. It's not as difficult as question 25, but it's difficult nonetheless. Okay. This is from May June 2024, paper 4, variant 2. Now A is projected towards B at a speed of 6 meters per second. ठीक है. And at the same time, C is projected towards B with a speed of V meters per second. ठीक है. In the subsequent motion, A collides and coalesces with B to form particle D. Particle D then collides with C to form particle E, and E moves towards C. अच्छा, अब हुआ क्या? हुआ ये कि this is what happened basically. A collides with B, ठीक है, and they coalesce. And are we given the speed? No. And then we're not given the speed. Okay. In the subsequent motion, A collides with B. Particle D then coalesces with C to form particle E, and E moves towards C. Okay, interesting. So there are 2 collisions. Then there is another collision which makes X, Y, and Z. So in the third collision, ये तीनों मिल गए. ठीक है. So A, B and C तीनों मिलके बन गए particle D नहीं E, and they're now moving towards Z. Okay, so this is particle D by the way, and this is particle E now, and they're moving towards Z. ठीक है. Okay, let's see what's going on. The question says, show that the speed after the second collision of E is 15 minus V upon 4. Okay, so first let's look at the first collision. Okay, let's look at the story of the first collision. ठीक है. अच्छा, अब मैं ज़रा थोड़ा जगह क्योंकि कम है, so we're going to utilize the space efficiently. So this is the before situation. Okay, and this is the after situation. Yeah. Momentum के सवाल में ये बड़ी अजीब सीन होती है कि वो स्पेस कभी तो बहुत ज़्यादा ही दे देते हैं, कभी बहुत कम दे देते हैं. खैर, anyway, so here's the mass, here's the velocity. So the mass of A is 5 kg, the mass of B is 1 kg. A is projected towards B at a speed of 6, okay, while B is stationary, okay. After the first collision, after A and B collide, what happens is this. When A and B collide, in the subsequent motion, A collides and coalesces. Yeah, so in the subsequent motion, A collides and coalesces with B to form particle D. Okay, so this is the part that we're focusing on. So that means their mass becomes the combined mass, and their velocity, we don't know, we can call it x. Achha, we are very short on space. Very, very short on space. So एक काम करते हैं. Let's squeeze this up. And let's squeeze this up also. Okay, so we're looking at 30 plus 0 is equals to 6x, which means x is equals to 5 meters per second. ठीक है? Okay, now this means that D now moves towards C at a speed of 5 meters per second. Okay, so after A and B collide, A and B combine and make particle D, and now they're moving at a speed of 5 meters per second. Okay, now we have to look at the second collision. So now when we're looking at the second collision, as far as the second collision is concerned, the particles that we have are D and C. Okay, and once again we are very short on space, so let's utilize the space efficiently. And then we have mass, and then we have the velocity, and then once again we have D and C, and we have the is tarah se to we'll run out of space. Okay, that's just horrible. So let's just do it without the table. So now we're talking about the second collision. Okay, so we're doing it without the table. So as far as the second collision is concerned, the mass of A and B have now combined, and the combined mass will be equal to 6. So that is 6 into the velocity at which they're now moving. So that's 6 into 5. Now bear in mind that C is also projected towards the combined particle. C has a mass of 2. Okay, and it is moving at a velocity of v. Now because it's moving in the opposite direction, we will take minus v. Okay, we will take minus v. Okay, and then what happens after these two particles, which apparently are 3, combine? All 3 become one big particle. These 3 particles become, all these 3 particles coalesce, so that means now the combined weight will be equal to 8. And what we are supposed to do is we're supposed to find out the velocity at which they're now moving. So I'm going to call that 8y. Okay, I'm going to call that 8y. Now 6 into 5 is 30. 30 minus 2v upon 8 is equals to y. And what is this? This is basically the velocity of E. This is basically the velocity of E. इसको हम 8 times VE बोल देते हैं for simplicity. This is the velocity of E. Now can we simplify? Yes, we can. In the numerator, we can take 2 common. And if you take 2 common in the numerator, what do you have? You have 15 minus V. And let the denominator be as it is. You can then simplify 2 and 8. 2 1s are 2, 2 4s are 8. So that means the velocity of E after the second collision is 15 minus V upon 4. And that's it. That's your answer. Can't I write 8VE? Yeah, I've written it as 8VE. Nice, Zuhair. ठीक है, yeah, part A is easy. The total loss of the kinetic energy of the system due to the 2 collisions is 63. Use the result from A to show that V is equals to 3. Yeah, all this for 3 marks. See, that's the thing about momentum. Momentum में there is no consistency. कभी पूरा पेज दे देंगे और सोल्यूशन 2 लाइनों का होगा, और जहाँ ज़रूरत है स्पेस की उधर दी नहीं है. अजीब, I don't know, it's messed up. खैर, anyway, so let's find out the initial kinetic energy. So the initial kinetic energy was because of this and this, was because of A and C. So what was A's kinetic energy? A was moving at a speed of 6, so half into A का mass कितना था? 5 into 6 square, plus kinetic energy of C, so that would be half into, wait, C had a mass of 2, sorry, half into 2 into V square. Okay, so let's write this nicely. 6 square is 36, 36 into 5 is 180, 180 upon 2 is 90, so 90 plus V square. So this is the initial kinetic energy. Okay, this is the initial kinetic energy. Now let's look at the final kinetic energy. Second collision again. So this is basically the scenario right before the second collision. The combined particle is moving at a speed of 5. So here you can see there we have taken their combined mass, which is 5 plus 1, that's equal to 6, and we've multiplied 6 by 5. ठीक है, मैंने यहाँ पे working इसलिए कम किया because जगह नहीं थी. And then plus, बेटा पीछे करके देख लो, ठीक है. I've just lost track of it myself. ठीक है, तो just watch that part of the stream again because we're not given a lot of space, so I've just lost track of working. So just go back to that part of the stream and watch it. ठीक है. Actually ये रही working of the second collision. ठीक है, चलो बता देता हूँ. So 6, 5 plus 1, 6. These two particles have coalesced and they're now moving at a speed of 5. So that's mass into velocity plus the mass of C, and since C is moving in the opposite direction, so that's minus V. And when the second collision happens, these three particles coalesce, so that's why we take their combined mass, and we don't know what the velocity is, so we write that as VE. Okay, since the combined particle is considered as E. How did you get 90 plus V square? So take the kinetic energy of A, since A is initially moving at a speed of 6, and take the kinetic energy of C, which is moving at a speed of V. A has a mass of 5, C has a mass of 2, so add them up, this is what you get. Now let's look at the final kinetic energy. The final kinetic energy looks like this. The final kinetic energy is, what does it look like after the second collision? After the second collision, all the particles have coalesced, so it's half into 8 into the velocity that we just worked out in the previous part, that's 15 minus 4 upon 8, the whole thing squared. Okay, this is the final velocity. So 2 1s are, 2 4s are. Now what we're looking at is 4 into 15 minus V, the whole thing squared, upon 16. So 4 1s are, 4 4s are, which means the final kinetic energy is 15 minus V, the whole thing squared, which will expand in the next step, we'll have to, okay, upon 4. Now there is a loss of kinetic energy. Loss means initial minus final. Okay, so initial minus final is equals to 63. Okay, do we need to consider the speed of D? Yes, of course. No. If you're talking about the initial, no. Initial means right before the first collision. Final means right after all the collisions that has happened, whether that's 2, 3, 4, doesn't matter. Okay. Now let's look at the final kinetic energy. So the final kinetic energy is 15 minus V, the whole thing squared upon 4. So initial minus final is equals to 63. That means 90 plus V square is the initial minus the final, which is 15 minus V, the whole thing square upon 4 equals to what? Equals to 63. Now, idhar bhi space, acha chalo idhar to there's plenty of space. So we'll have to first expand. So we're looking at 90 plus V square minus, no, not final minus initial. Final minus initial will give you a negative value. If you're doing final minus initial, in that case, you will take minus 63. Okay. See, if you're taking loss is selling price minus cost price. But if it's a negative profit is selling price minus cost price. Okay. So loss will be initial minus final. Achha, 90 minus V during the initial. Now, why would I do 90 minus V? Where's that coming from? Now, why would I subtract? अच्छा चलो, even if they're moving in the opposite direction, चलो मान लेते हैं they're moving in the opposite direction, which they are. तो बेटा kinetic energy, it's minus v the whole thing square. So ultimately it's going to be plus v square. Kinetic energy is going to be positive. Okay, even if it's moving in the opposite direction, the speed gets squared, so it's going to be positive. Okay. So 225 minus 30v plus v square upon 4 equals to 63. So now let's multiply everything by 4. Let's multiply everything by 4. Okay, so this is just another way of taking the LCM. So 4 times 90 is 360 plus 4v square minus, यहाँ पे don't forget to put a bracket, so minus 225 minus 30v plus v square equals 63 times 4. What is 63 times 4? That's 252. Okay, there is a lot going on here. अच्छा, अब मैं ना थोड़ी cheating कर रहा हूँ. I'm just writing down the simplified version. So 3v square minus minus will make it plus 30v. So 360 minus 225 minus 252, that's minus 117 equals to 0. Okay, now let's take 3 common. So if I take 3 common, we have v square plus 10v minus 117 divided by 3, which is equal to 39. Yep, I do agree this is a lot of working for just 3 marks. I do agree. So we have v square minus, but the good news is okay, we're almost there. V square plus 10v minus 39 equals to 0. So factors of 39 that give you 10, that's going to be plus 13 and minus 3. Minus 39 equals to 0. So v into v plus 13, then let's take minus 3 common. So we have v plus 13 equals to 0. So we have 2 possible values of v. V is equals to 3 and v is equals to minus 13. So both of them are technically possible. Both of them are technically possible. But the thing is, which one are we going to take? We're going to take the positive one. Why? Because they're moving towards z. So they're now moving towards the direction that we have considered positive. So that means the value that we're going to take is v is equals to 3. In fact, I think this is a show question. Yeah, this is a show question, right? So v equals to 3, and there you go. Hence shown. Okay. Yes, beta, you can't answer in columns. It's not that I said it earlier and now I'm saying you can't. You can. You can't answer in columns. Simple as that. ठीक है. अब इसमें मैं elaboration क्या दूँ बेटा? Just don't write the answer in columns. नहीं बेटा, आयरा आज S1 की क्लास नहीं होगी. कल M1 का एग्जाम है. तो S1 इंशाल्लाह we will double down on from the 6th, which is tomorrow. Why we reject the negative sign? Negative sign means that it's now moving in the opposite direction, which it's not. Okay, these combined particles are moving in the direction that we have considered positive. So that's why we take the positive value. Okay. Why are these so hard? I'm deliberately solving the difficult questions. Okay, I'm deliberately solving the difficult questions. That is why. What are columns? भाई क्या मतलब columns यार? ये column बना के working नहीं करो. इसमें इतना परेशानी की क्या बात है? Just don't make a column and do your working in columns. That's what I'm saying. Simple as that. I don't understand why that's such a big deal. But sir, v was towards the left. No, it's not towards the left. मेरे भाई सवाल पढ़ लो. They're moving towards z. That means they're moving towards the right. Right is the direction that we've considered positive. ठीक है. C left को move कर रहा है, but we're talking about the final collision. Okay, we're talking about after everything that has happened. These 3 combined particles are now moving towards the right. ठीक है, खुदा के वास्ते एग्जाम में ये नहीं करना, सवाल पढ़ लेना. These 3 combined particles are moving towards the right, which is the direction that we have considered positive. ठीक है, clear हो गया अब? Okay, now part C. So there is more. Ya Allah khair. It is given that xy equals to 36 and the distance yz is 98. Find the time between the 2 collisions. Okay. So I think this is a relatively easy question. Yeah, let's use this. S1 inshallah I'll start from tomorrow. Okay, now xy का जो distance हमें दिया हुआ है, notice that we now have the value of v also. Okay, we now have the value of v, which is 3 meters per second. Okay, and we're told that xy distance is 36, not drawn to scale, and yz distance is 98. Find the time between the two collisions. Okay, so first let's talk about the time that A takes to travel from x to y. Okay, so the time that A takes to travel from x to y. So time is equals to distance upon speed. The time is equals to the distance, which is 36, divided by 6, and that's equal to 6 seconds. Now, is it possible that in the meantime this particle, this particle collided with B before 6 seconds? Let's find out. Is it possible that C actually collided with particle B within those 6 seconds? No, it's not possible. Why? Because if I look at C, and if I look at the distance that it travels in these 6 seconds by doing simply time into speed or speed into time, we notice that it does not collide. Why? Because the distance that C travels in these 6 seconds is equals to 3 times 6, which is equal to 18 meters. So that means what C has done in these 6 seconds, it has moved 18 meters closer. Okay, it has moved 18 meters closer. Okay, and now it is 80 meters away. And now these two are 80 meters away. ठीक है, तो मैं दोबारा बता देता हूँ. So what has happened in these 6 seconds? After 6 seconds, this is what the situation looks like. ठीक है, let's draw it separately. So this is the situation after 6 seconds. ठीक है, pay attention. We're short on space, so we have to utilize it efficiently. So here's A. Here is B. Okay, so these two have collided. A has moved from x to y. Okay, it has covered 36 meters. Now here is Z, and this distance was 98 meters. Okay, and this is where C was. Now after 6 seconds, this is where C is now. Because it took A 6 seconds to collide with B. Now that 6 seconds have passed, C was continuously moving during those 6 seconds, and in those 6 seconds it has traveled what distance? It has traveled a distance of 18 meters. ठीक है, in 6 seconds में C ने 18 meters का distance cover कर लिया, which means now they are 98 minus 18, which is equal to 80 meters apart, and A, B combined is moving at a speed of, what was the combined speed of AB? 5 meters per second. Okay, we got that in the previous part, that AB combined were moving at a speed of 5 meters per second right here. So AB combined are moving at a speed of 5 meters per second, and C is still moving at a speed of 3 meters per second. Okay. So what is time equal to? Time is equals to distance upon speed. What is the distance that we're going to take? We're going to find out the distance apart. And what are we going to do with the speeds? We're going to take the combined speed. Why? Because they're moving in the opposite direction. So the distance apart is 80. The combined speed will be 5 plus 3. And what's that equal to? That's equal to 8. So 80 upon 8 is equals to 10 seconds. Okay? Now don't get carried away. 10 is not the final answer. Final answer क्या होगा? Final answer होगा, find the time between the two collisions. सही है, find the time between the two collisions. So it is 10 seconds. So after the first collision, it takes 10 seconds for the second collision to happen. So the time between the two collisions is 10 seconds. ठीक है? So I'll repeat. So notice that A was projected towards B at a speed of 6 meters per second. C was projected towards B at a speed of 3 meters per second. Now clearly A has less distance to cover and more speed, so it will collide with B first. Okay? And it will take 6 seconds. Obviously, C is not just going to sit idle for those 6 seconds. C has a speed of 3 meters per second. So that means for 6 seconds, it will continue to move at that speed, and it will cover 18 meters in those 6 seconds. So that means after 6 seconds have passed, this is where C is at. It has traveled 18 meters from the starting point. That means now these two combined particles are 80 meters apart. Why? Because they were initially 98. C has covered a distance of 18. That means now they are 80 meters apart. Okay. So what is the time for these two particles to collide once again? We will take the distance apart, which is 80, and we will take their combined speeds, which is 5 plus 3, that's equal to 8. So 80 upon 8 is equals to 10 seconds. ठीक है? अब दुआ करोगे ऐसा सवाल पेपर में ना आ जाए. Yeah, this is see, the thing is, it's very easy to lose track of these questions. It's very easy to lose track of what's happening in the question. Acha, wait, it's not over yet. Okay. Then there is part 2. चलें part 2 भी कर लेते हैं. Find the time between the instant that A is projected from X and the instant that E reaches Z. Okay. Okay. Acha, अब these two particles will take 10 seconds to collide. अच्छा, मुझे सोचने दो. अब 10 seconds में क्या होगा? 10 seconds में find the time between the instant that A is projected from X and the instant that E reaches Z. Okay. So, all right. Here is X, here is Y, and here is Z. So, ये आपके पार्टिकल A और B आ गए, ठीक है, और ये आपका पार्टिकल C आ गया. Now it takes 10 seconds for this collision to occur, which means that AB will travel a certain distance in those 10 seconds. Okay, so AB के बारे में देखते हैं कि what is the distance that it travels in 10 seconds. So the distance is equals to speed into time. So that means the distance that it travels is equal to 5 into 10, that's 50 meters. Okay. Now this means that here is Y, here is Z. Okay. And this distance is 98 meters. And AB has traveled 50 meters. AB has traveled 50 meters. That means it still has to travel how many more meters? It still has to travel 48 more meters. Okay. And the question is, after the final collision, after it collides with C, what is the speed at which it's traveling? It's traveling at a speed of 3 meters per second. So what will time be equal to? Time will be equal to distance upon speed. The distance that it has to travel after it collides with C to reach Z is 48 meters. And what is the speed at which it's traveling? It's traveling at a speed of 3. So 48 upon 3, what is that equal to? That's equal to 16, I believe. Yeah, 48 upon 3 is equals to 16. So that means now the total time from the beginning to the end is 6 seconds for A to reach B. Okay, so that's 6 seconds. Then another 10 seconds for C to come and collide with A and B. So that's 10. And then another 16 seconds for these three particles combined to reach Z. So 6 plus 10 plus 16, that's 16 plus 16, which is equal to 32 seconds. ठीक है, मज़ा आया? Yep, for 1 mark. ओके अब यार एक सवाल और करते हैं, वो वर्टिकल वाला कर लेते हैं और फिर एंड करते हैं. ठीक है, अभी पूरा सिलेबस रन थ्रू भी करना है. 19 is on the easier side. Okay. Instead, I'm going to do question number 23. Okay, so 19 is on the easier side. Instead, I'll do question number 23. सही है बेटा 25 ना मेरी लास्ट मोमेंटम की स्ट्रीम से देख लो 25 इंतहाई कोई मुश्किल सवाल है and it's मुश्किल for no reason. It's so difficult that so many students did it wrong and they accepted the wrong version of it. So I feel like there's not going to be much learning by solving question number 25. We can do it for fun, but now is not the time for that. ठीक है? Okay, now, a particle P of mass 0.2 kg is projected vertically upwards from horizontal ground with speed 25. Show that the speed of P when it reaches 20 meters above the ground is 15. So this is a no-brainer. 2as equals to v square minus u square. The initial velocity is 25. See, notice that it has given you the mass. That means it's clearly pointing towards momentum. Sir, I thought momentum was an easy topic. Well, you were wrong, clearly. And acceleration due to gravity is minus 10. Displacement is displacement is 20. And we have to show that v is equals to 15. Okay? Okay, so we'll just figure out v and see if it's equal to 15. So 2 times minus 10 times s is equals to v square minus 25 squared. Math P2 was even easier than P1. So that's nice. That's nice. So 2 into minus 10 into 20 plus 25 squared. Let's take the square root of it. So v squared is equals to 225, which means v is in fact equal to. Yeah, I will take a break. We'll take a break before we do the syllabus run through. Don't worry. When P reaches 20 meters, it's not that you need a break. I need a break also. When P reaches a speed of, when P reaches 20 meters above the ground, it collides with the second particle of mass 0.1 kg, which is moving downwards. P is brought to instantaneous rest in the collision. Find the velocity of Q immediately after the collision. Okay, now, a good idea would be to make a rough sketch. Okay. Yes, beta, I will do S1, but I'll do S1 after. I'll do S1 from tomorrow, okay? So just stay tuned. Tonight I'll announce my streams for tomorrow, don't worry. So this is the horizontal ground. And from here, you have particle P, which is 20 meters above the ground. Correct? And when it is 20 meters above the ground, it collides with another particle Q, okay, which is moving downwards at a speed of 20 meters per second. No, wait a minute. P is moving upwards at a speed of 15 and it's 20 meters above the ground. Yeah. And it's moving at a speed of 15 meters per second. Q, on the other hand, right before the collision, is moving downwards at a speed of 20 meters per second. Okay? Okay. Now, Acha, what's next is that after the collision, P is brought to instantaneous rest. Now, iska matlab ye nahi ki it's just going to remain in the air stationary. It's just going to be dangling, not dangling, it's just going to pause in air. Okay, it's just that it's going to be instantaneously at rest and then it will continue its way down. Okay, so this is the before situation. And what happens after is this. Is that P's velocity is momentarily equal to 0, okay, whereas Q's velocity we have to find, okay. So after the collision, P's velocity is equal to 0 and Q's velocity is what we have to find, okay. And also the direction, because we don't know whether Q will continue to move down or whether Q will move up. So the question is, what is the velocity of Q? That's what we're supposed to find. Okay? We have to figure out, we have to decide which side is positive, which one is negative. So let's take the upwards side as positive. Okay? Because we have particles moving in two different directions. So let's take the upwards direction as positive. You can do the other way around also. Doesn't make a difference. Okay? Now, so how much space do we have? Plenty of space. Before, after. So we have P, we have Q, we have mass, we have velocity, P, Q, mass, velocity. So mass of P was 0.2. Mass of Q is 0.1. P is moving up at a speed of 15. Q, on the other hand, is moving down at a speed of 20. So we're going to write minus 20. Now, the mass obviously remains the same because they don't coalesce or anything. Yeah, they don't. 0.2 and 0.1. And P comes to rest. We have to find out the velocity of Q. Okay? We actually have to, we have to find out the velocity of Q. So 0.2 times 15, that's equal to 7.5 minus, so 0.1, 0.2 times 15. No, wait a minute. That's not 7.5. मैंने 15 को half से multiply कर दिया. So that's 3 minus 0.1 times 20. What's that equal to? That's equal to 2. Is equals to 0 plus 0.1 VQ, which means if you solve for the velocity of Q, that's equal to 10 meters per second. Okay? And the fact that it's 10 tells you what? Tells you that it's moving upwards. The fact that it's positive 10 tells you that it's moving upwards. Right before the collision, it was moving downwards. After the collision, the velocity has turned out to be positive. That means now it's moving upwards. So make sure that you keep your eyes and ears open when you're solving this question. Sir, do we need to mention the direction of Q? No, you don't have to, considering that you have already mentioned this. You don't have to mention the direction, but this is for your own sake. Because you have to make use of this information in the following part. Okay? All right, now part C. What year is question 25 from? Beta, worksheet download करके देख लो ना, इसमें इतना मुश्किल काम क्या है? It's October, November 2021, paper 4, variant 2. Okay, now. When P reaches the ground, it rebounds back directly upwards with half the speed that it had immediately before hitting the ground. Find the height above the ground at which P and Q next collide. Let me think. So let's find out how long it takes P to hit the ground. Why? Because after collision की जो situation है वो ये है. Collision के बाद वाली situation is that Q is actually going up. Okay, Q is actually going up at 10 meters per second. Okay, and P, if P comes to rest, that means what will it do after that? If it comes to rest, now it will start traveling in the opposite direction. Okay, after P comes to rest, it will now start traveling in the opposite direction. Okay, so here is P, which is now going to travel downwards. Okay, and the distance that it's going to travel downwards is 20 meters. The initial velocity is equals to 0. The acceleration due to gravity is 10. Okay, and we have to find out the time that it takes. Okay, so the formula that we can use is S is equals to ut plus half at square. So S is 20. 20 is equals to 1 upon 2 into 10 into t square. So that means t is equals to 20 times 2 is 40. 40 upon 10 is 4. So t is equals to 2 seconds. That means P takes 2 seconds to reach the ground. Okay, P को लगते हैं 2 सेकंड नीचे आने में. सही है? Yeah, this is the last question. This is the last question. I'm not solving any more questions, guys. I know you guys would want me to solve more and more questions, but let's just pull the plug now. Okay? But we are doing a syllabus run through after this. Don't we need to find the speed? You mean we need to find out the speed before it hits the ground? We could, but how is that going to help? We could find the speed, but how is that going to help? We need to find out the height above the ground at which P and Q collide. अब देखो, please understand the journey. P takes 2 seconds to reach the ground. Okay. And during those 2 seconds, Q will continue to travel up. Okay. Actually, it will travel up, and then at the same time, it will come back down also. It will travel up and it will come back down also. Okay? So let's find out what has Q done in these 2 seconds. Okay, let's find out what has Q done in these 2 seconds. Okay? Q ने इन 2 सेकंड क्या किया वो हम देखते हैं. Let's find out the displacement of Q. So the displacement of Q is what we want. The initial velocity of Q is equals to 10. The acceleration due to gravity is minus 10 and the time is equals to 2 seconds. So the displacement of Q is equals to ut, that means 10 times 2 minus 1 upon plus 1 upon 2 into minus 10 into 2 squared. So this turns out to be SQ is equals to 20 minus 5 into 4, which is 20. Oh, that's equal to 0. So that means the displacement of Q is equals to 0. That means what did Q did in these 2 seconds? Q went up and it came back down. Okay, so Q went up and it came back down. And now after the 2 seconds, when P hits the ground and Q is at the same point. Okay, so this is basically what it looks like. This is what the situation looks like after 2 seconds. After 2 seconds, this is what it looks like. This is the ground. This is P. So we will have to find out the speed. You're right. We will have to find out the speed. Why? Because it will rebound at half the speed. So we need to find out the speed at which it hits the ground. Yeah, we do need to find out the speed. You're right. Since Q's displacement after 2 seconds is equal to 0, that means in these 2 seconds, it went up a certain distance and it came back down. That is why its displacement is equals to 0. Achha beta, this is the last question that I'm solving, so please no spamming. Okay? This is the last question that I'm solving. I'm not going to be solving any more questions, so I would appreciate if you stop spamming now. Now, P and Q are 20 meters apart. Okay, P and Q are now 20 meters apart. ठीक हो गया? Now, let's find out the velocity of P as it hits the ground. As it hits the ground. So the velocity of P as it hits the ground can be worked out by taking the initial velocity, which is 0, acceleration due to gravity is 10, and the time that it takes is equals to 2. So V is equals to U plus AT, that means 10 into 2. So the velocity with which P hits the ground is equals to 20 meters per second. Okay, so what will be the rebound velocity? Or not velocity, actually, rebound speed kitni hogi? Half, that means 10 meters per second. Okay, so this is the velocity with which it will rebound. Screen is stuck. Oh yeah, screen is stuck, you're right. Let me refresh. Okay, so I'll explain what I've done. Dekho, so this displacement of Q is equals to 0. That means it is at the same point of collision. The velocity of P as it hits the ground is equals to 20. That means the rebound speed is equals to 10 meters per second. Okay, I will just be doing a syllabus run through, just the revision. That's it. Okay, I'm not going to be solving a single question in the syllabus run through. Okay. Achha, here is the situation. So this is now moving up at a speed of 10 meters per second. Q is also now moving down at a speed of 10 meters per second. Why is that? Pay attention. Remember, kinematics mein the motion is symmetrical. Right after the collision, its speed was 10 meters per second. That means on the way down, when it reaches the same point, its speed will be 10 as well. Okay, so Q right after the collision of P had speed 10 meters per second. It went up, and in 2 seconds, its displacement is equal to 0. That means it is now back to the point of collision. And at that point, its speed will be equal to 10 as well. Okay. How did I find the rebound speed? Just take what is the speed of P in 2 seconds, because it takes 2 seconds to hit the ground. Okay. Now, where were we? Yeah, the rebound speed is 10 meters per second. Okay. Achha, the situation is this. Here is P moving down at a speed of 10 meters per second. Here is P moving up at a speed of 10 meters per second. The question is, how long will it take for them to collide? Let's see. So let's find out the displacement of P. That's going to be 10t plus 1 upon 2 into 10 t square, which means the displacement of p is equals to 10t plus 5t square. ठीक है, ये 6 मार्क का सवाल है, so ज़ाहिर वर्किंग तो करनी होगी. Let's find out the displacement of q. So that's going to be, sorry, minus 10. Why? Because it's going in the opposite direction. Minus because it's going in the opposite direction. So the displacement of p is equals to 10t minus 5t square. How did you find the rebound velocity? I've already explained that. Okay. Find out the velocity with which p hits the ground. That's 20. The rebound velocity is half, as mentioned in the question. So half of 20 will be 10. Now, what about the velocity of the displacement equation of q? That's going to be equal to 10t plus 1 upon 2 into 10t squared. No, why would it be midpoint? For what reason would it be midpoint? No, p will actually be traveling in the opposite direction when they collide. ठीक है, अभी देखते रहो, ऐसे फजूल के assumptions that you can't back them up ना किया करो. SQ is equals to 10t plus 5t square. Now when they collide, SP plus SQ is equals to 20 meters. Okay, so the displacement of P plus the displacement of Q will be equal to 20. Whenever they collide, that means their combined displacement will be equal to 20. Okay, now let's add them up. 10t minus 5t square, okay, plus 10t plus 5t square is equals to 20, which means minus 5t square plus 5t square cancel. 20t is equals to 20, which means t is equals to 1 second. Okay. Now, if t is equals to 1, what do we have to do? We now have to find out how much space do we have? Okay, we're almost out of space. We now have to find out the height above the ground at which P and Q next collide. So in order to find out the height of P, what we have to do is simply plug in the displacement equation, simply plug in the value of T. So that's 10 into 1 minus 5 into 1 squared. So we get the displacement of P, and that is equal to 5 meters. And notice that is not the midpoint. That is not the midpoint. Okay, so why u of q is 10 here? See, for u we've taken the downwards direction as positive, for p we've taken the upwards direction as positive. Okay, because we're making two separate equations, so we can do that. But if you have two particles that are moving in opposite direction in the same equation, you can't do that. Okay, I'll give you guys a summary of this. Pay attention. I'm not solving any more questions, guys. That's it. Okay. So, when P reaches the ground, it rebounds back directly upwards with half the speed that it had immediately before hitting the ground. So this means that after the collision, P becomes stationary, but obviously it's not going to pause in the air. It's going to start moving in the opposite direction now. Now what's going to happen is this. Q will move up, P will move down, and when Q starts traveling downwards, then it will collide with P. Okay, and it could be that P is then on the way up or it's on the way down after rebounding. We don't know. That's what we're going to find out. So let's find out the time that it takes P to hit the ground. So the distance is 20. Since it's 20 meters above the ground, it's moving down. So acceleration due to gravity will be positive 10 since it's moving downwards. Okay, so S is equals to ut plus half at square, and we get 2 seconds. That means P takes 2 seconds to hit the ground. Now what we need to do is we need to find out what does Q do in the 2 seconds. Okay. What does Q does in those 2 seconds? So Q's displacement in those 2 seconds is 0. That means in these 2 seconds, it went up and it came back down, and now it's back to the same point. Okay. Now, this is the situation after 2 seconds. Q is moving down, P is moving up. P is moving up at a speed of 10. Why? Because it hits the ground at a speed of 20, and the question says that it rebounds with half the speed. So now it's moving up at a speed of 10 meters per second. So then what happens? their combined displacement needs to be equal to 20. For them to meet, their combined displacement must be equal to 20. So we find out the displacement equation of P, we find out the displacement equation of Q, we add their displacements and we equate it to 20. Then we get the value of T, which is equal to 1 second. That means both these particles now travel for 1 second for the collision to take place. Up the question is, what is the distance of P above the ground? So for that, we plug in the value of T into the equation, into the displacement equation of P, and we get 5 meters. That means P is 5 meters above the ground when this collision happens. Okay? So that's it, fellas. That's it for momentum. Okay, I think we've done plenty of momentum now. And now it's safe to take a break. So yeah, अब हम इस stream को इंशाल्लाह यहाँ पे ख़त्म करते हैं. We'll start another stream where we will do a syllabus run through. Okay, it's just going to be a very short syllabus run through. Please don't expect me to cover everything in detail. I'll just be going over my notes. Okay? So that's it, fellas. See you guys in 15-20 minutes. Okay? Won't you take U with A negative? No, we're not going to take U with A negative because it's moving. For Q, we're taking the downwards distance as positive, or downwards direction as positive, and for P, we're taking the upwards as positive. So we're not going to take it as negative, okay? 7:30. Chale. So see you guys at 7:30 inshallah. Take care everyone. Allah Hafiz.